This conference will now be recorded.
Hello everyone, welcome to our day 19 in our GCP Cloud Architect training. So last week we stopped at this slide where we finished data store and file store, and we just stopped it here. And last week what happened is the last 1 hour recording somehow did not happen. Maybe I guess I forgot to press the record button after we took the second break, so the 1 hour recording would be missing. So basically the data store firestore recording is missing. Thanks to Sridevi, she mentioned that this is missing, so I'll record it again separately and attach it, folks, to the day 18 recording. Currently, if you see, it is only 2.5 hours or something. Usually with breaks removed, it should be 3.5 hours recording. So I'll make sure I fix that recording part on the day 18 part. Okay. So give me some time. So maybe by next week or next to next week, I'll just record it. So I have to record it alone and upload it. So I'll do that. Okay. So today what we'll look into is cloud big table. As I mentioned, this is one of the a database which Google uses, a NoSQL database which Google uses for most of their end user products like the YouTube, Gmail, Maps, Google search engine. So this is a database which powers most of the end user products. And if you see, YouTube has a 1 billion user base. Maps has 1 billion user base. Gmail has 1 billion user base. So totally, if you add up, it's going to be something like 4 to 5 billion user base is what this big table currently supports. So it's really the technology which is heavily used by Google. And the same thing is Google has shared the open source community with the form in the form of something called as Apache Edge Base. So if you have worked or if you have heard of it, it's basically going to be helpful. The reason is this is going to lead to a left hand shift. So in on-prem, if you have basically Apache Edge Base, moving to on-prem, moving to GCP means big table. This is what you can do. So it's going to be a left hand shift. It's going to be a left hand shift easily when it comes to GCP. So whenever you hear the word edge base, think of that this is a possibility of a left hand shift stuff which you can do. Um, I'll try to add this in the implementation cheat sheet so that you can keep a track of that. Left hand shift simply, and it's the open source implementation is by based on the white paper which Google has shared with the community. So cloud big table, simple. I guess most of them have joined. Now let me make a small uh, information shared. Now it's almost like now 18 classes are finished. Now you are getting used to the GCP terms, terminologies, all those things, right? So, and everybody has a GCP console. What I would strongly suggest is at least once in a day, at least for 5 minutes or 10 minutes, come to GCP console. I know with your hectic work, office work, it would be difficult if you're not working on GCP, but at least 5 minutes or something, if you come to the GCP console, the free trial account, you'll see something called as usually a news widget, which would be always at the bottom. It would be something like this at the bottom. What I would suggest is drag this, bring it to the top, right below Google status, Google Cloud Platform status, and look at some of the news, GCP related news. That's going to expand your understanding, your how things are working. For example, there's a 2 days back interesting story or an article which was created called as rethinking, rehost, replatform, re-architect. This is basically the migration strategy which people use in any cloud. So this is a nice article, folks. So I would suggest to look into this kind of articles. By this way, what you are going to do is basically, by the time we finish our class, so you will have good amount of understanding of the concepts, and also you are keeping in pace with the latest news which is coming. Maybe those things can lead to some good understanding. So rehost is basically, in simple terms, called as lift and shift. You're changing the host where it is running. If it's running in on-prem, change it to GCP. That's rehost. So this is the same thing which we are going to learn in our module 9. Module 9. And this article is really, really good. I would strongly suggest you to spend at least 20 minutes towards the end, right? They also share different people's different cloud stuffs approach towards migration. For example, every time the migration happens, they usually use that R: rehost, re-platform, re-architect, re-factor. So there are different R's. So look into those R's. So we will talk about 7 R's in GCP. AWS talks about 6 R's. So strongly suggest you to take a look into this thing. We are going to touch this in our module 9. So this is a new article. Look into it. And there's going to be some other article about celebrating women in tech. Please check your bill in Google Cloud Storage. So, but the last 2 days, the one which was interesting for me was this article, more towards cloud architect part. Okay, so keep an eye. And sometimes if it's a really a good article, I feel I usually post it in my LinkedIn also, so that people who have missed it can see it here. So make it as a habit, folks, at least till you finish your certification. So that way your attachment towards GCP will always increase. Just thought of sharing that. Let's go back to Cloud Big Table. CBT is a short form which they use. Even in the exam, I have seen a question where they just use the acronym. So just getting used to the acronym sometimes is going to be very, very important. CBT. So for me, when I saw the question for the first time, took a minute for me to understand what is CBT. Later realized that it is Cloud Big Table. So it's worth putting that also in the cheat sheet. Even though it looks very simple, in the exam even every minute counts, so let's not make even think. CBT stands for Cloud Big Table. So what is this? This is something in a petabyte scale, low latency non-relational database, or a NoSQL database. There are equivalents of this in AWS called as DynamoDB, and in Azure it is called as Azure Table Storage. So what is this CBT all about? Let's look into it. So it's a NoSQL database basically, which is fully managed by Google. And there's a specific term which people use: NoSQL wide column database service. What is this wide column? Basically, to understand this, let's take an example of lots of sensors, IoT devices mounted on the highways. Okay, so the example which we took last time also while doing data store, it's the same example. So if I just take that example, I have sensor 1, I have sensor 2. Both are from the same manufacturer, both has the capability to send good amount of telemetry information, something like information like raining in that specific highway. Is it raining? If raining, the centimeter, the measure of rain, traffic congestion is there or not, then um, some other information about the road. So these can send all those information easily. But assume this is in a place where it always rains. It always rains most of the time, something like that. A place where it is little rainy. It is that's a place where it has been mounted. Place where it's it is always raining. So sensor 2 is totally opposite. It's always very hot in that kind of a place. You can take an example. So place where it is hot most of the time, always. Now, same information, same kind of sensor mounted, because they would have got a order from a specific vendor. So it's going to have the same thing, uh, something like temperature in this case. So if you see, all this information goes to a centralized database, usually for doing some kind of an analytics. Now, assume I have these kind of sensors all across the world, or sorry, all across the country, or all across a specific a state. If this kind of information keeps on going from some sensors, for example, sensor 2 will never give me an information about rain, about the measure of rain, meaning that column, right? Because anyway, it's all database. So you're going to talk about in terms of rows and columns. That column is always going to be empty or null, correct? So that's what is going to happen. Now, what this wide column database means is, usually in database there is a concept called as normalization. So if you have basically a relationship between two tables, employee uh, and what or maybe employee and projects which the employees work on, so there is a relationship between these two tables, right? So they usually separate the columns. So employee table may have some 10 columns, the projects may be having around 6 columns, so totally 16 columns. But usually as per the DBA, the tables are going to be separated into two tables. This is one of the normalization factor where people have to separate it, so that it's easy to query all those things, easy to query, transact all those things. That's how people usually do in Oracle, MySQL, any relational database. But when it comes to NoSQL database or non-relational database, usually the tables are denormalized. What do you mean by denormalized? Basically, put everything in one table. You want employee information, the projects the employee works on, put everything in one table. So 16 columns are going to be in one table itself. Now, some fields may be empty, some fields may be null, some fields may be having a value. Now, if you are coming from a database background, a table, now the moment you see a table having very long, a very like something like 100 columns, you will definitely say as a DBA, you have to divide this, you have to separate the tables. So having 120 columns or 100 columns is not a good practice in a normal database. But in non-relational database, this is the practice. The reason why, at least in big table, they keep the number of columns very wide is basically, okay, so denormalized, sorry, my bad, denormalized. So it's denormalized. So when it comes to big table, right, you can have a very high number of columns. And why that is an advantage is, it's going to be easy to query. Every information is in one table itself, folks. So no need of putting joins or anything. So it's going to be little easier for you to do analytics, query it faster. That is one advantage which you get. And another big advantage which you get is, going back to the example of the sensors. So if you see here, so when it comes to sensors, right, all this goes to one table, something like highway sensors in big table. So if for some sensors that raining and measure of rain is empty, that space is not going to be taken, folks. If it's raining, assume it's a Boolean. For a Boolean data type, there's going to be a size which is going to be taken. For measure of rain, it's going to be in centimeters, some kind of a unit, uh, integer or something. So what is the size for an integer variable to take? So there's going to be some size, right? So if the field is empty or it is null, it is not going to take space on your storage. This is the beautiful feature which you get in big table. If you are coming from a database background, go check it. Even if the field is empty in your relational database, it's going to take space, the storage space. But in big table, it does not take it. So now it makes it a little unique to use wide columns, so that even if the fields are empty, it's okay because the tables are sparse. Basically, they don't take space. The columns, if the columns are empty, it does not take any space. It's totally zero. This way, if you denormalize it, it becomes very easy to query. And big table is a NoSQL database. So NoSQL database are primarily not a good fit for transactions. They're always good for doing some kind of analytics. So because everything is in one single table, and if there is no data, it's not going to take space. It becomes easy for me to query it with very, very low latency. Very, very low latency. Low latency as how much? As low as 6 milliseconds. 6 milliseconds. 6 to 10 milliseconds is what I can get basically. This is a very important thing with BigQuery. So low latency. So any kind of, and this big table, right, usually becomes more better as you push in more data. And this works very well for a time series data. Uh, for example, data which keeps changing on time. For example, your stock price, rain in a weather report in a specific city or a state or a country, which is time axis bound, right? So if you are data which is sent from an IoT device continuously, the device is always sending data. So there is going to be some information on the time, right? So whenever you are working on a time series requirement, and you want to do some analytics on that, Bigtable is a great fit, and it's going to retrieve you the information and show you with very low latency. Just imagine if you are having some background from the stock market. You can see, if you just open the stock market, any website, you can see the stock price tickling so fast. Now if you were to do some kind of a decision, if the stock price of this specific company increases or decreases, I have to do an action. So you have to do something which is very, very quick. So in that kind of a scenario, Bigtable is really a good choice. Similarly, Bigtable comes very handy when it comes to recommendation. So if you're in any e-commerce website, for example, Flipkart or Amazon, if you are purchasing, say for example, a phone, the recommendation should be people who purchase this kind of a phone also purchased a flip cover, a scratch guard, maybe extended their warranty, something of this sort, right? These are all additional stuffs which you can recommend. uh, if your recommendation is very slow, you may lose the customer. Say for example, the customer comes the moment you add your phone into the cart. If showing your recommendation that people who bought this also bought this, it's very instantaneous. Then there's a thought which goes behind the person who's buying this. Maybe he can add this item to the cart. So that latency is very, very important. But if you purchase the phone, do the checkout, do the payment, afterwards if you get a recommendation, the person will think, anyway I paid it, I did a transaction, next time I will do it. So it's going to be postponed. So whenever you have this kind of a very low latency requirement, in this case of recommendation or in financial sector, like the stock market tickling, based on that you take a decision. Big table comes very, very handy because this is one of the database where you get very low latency. The whole reason is the architecture in it, how the data has been written, how you query it. We'll see that at a good high level today. So that's the key part. And it can also be used for some kind of a graph database. So if kind of a relationship, if you wanted to create, for example, in Facebook, you create, right? My friends have X, I have 10 friends. Those 10 friends have 20 friends. So you want to create a graph, that's going to be also another possible choice. So a small hint here, at least from the exam perspective, is wherever you hear the word analytics, and whenever you hear that low latency is the key part, big table could be a good choice. Analytics, not for transaction, because NoSQL database are not good for transaction. So a database or a requirement where you have low latency analytics, uh, then petabyte scale. Fit is time series data, IoT IoT analytics or IoT data, then uh, then something on time series. These are some keywords which hints basically cloud big table. So these are some hints which you can keep, folks, as a keyword. So announce cloud which eliminates the need for. So I have not even looked into it, Vivek. So I'll look into it and I'll maybe tomorrow I'll talk about it. I have not looked into that announcement itself. Uh, what is that connectivity center? Never seen it. I'll look into it, please. Tomorrow I'll just look into it and tell you that. So that's cloud big table, and usually, right? Firestore or data store is also NoSQL database. Now you may slightly get confused. When should I use what? If the data is more towards a document, a kind of a hierarchy, uh, like your product catalogs, to store your product catalogs, kind of a stuff, Firestore is a good choice, or a data store is a good choice. And the volume is in terabytes, it's always a good choice. Um, but the volume is going to be in petabytes and it's going to continuously increase if that is a kind of requirement. And if it's in petabytes, usually I would prefer to use big table. Prefer to use big table. Prefer to use big table. Now let's look into the table structure. You may ask, tables are always tables, right, Mahesh? What's the difference in this? But the way tables are organized, or the concept of tables in big table is slightly different. It's not always your rows and columns. Uh, Wide column means a good number of columns, basically. Yes, Arvind. So the number of columns are going to be always very high because it's basically two tables or three tables put in the same table structure, denormalized fashion. So that is the reason we usually call it as wide column database. So because this structure itself is different, right? Let's spend a minute here to understand the table structure in our big table. So remember last week we did on Spanner, where we talked about a singer and album details, right? It was two different tables in a relational database. Spanner is a relational database. We had two different tables, singer table and uh, album table. If you were to do the same thing about the list of all singers and the albums they created it, and if you were to have it in big table, this is how the table structure is going to look like. There's something special in this table structure. What is that? You have something called as column families. This is a term which big table uses specifically. What is this column family? If you were to map it in very, very simple terms, it is nothing but one table. One table is one column family. So because in big table everything is denormalized, so you will have n number of tables, meaning you will have n number of column families. So one column family for personal information, first name, last name, the about the singer. Another column family, in simple terms, another table, which is the albums. So that is another column family. So you have everything in one table. So you usually have column families, and each column in a table, in a normal table which you would have seen in relational database, is going to be called as column qualifiers. So first name, last name, album name, year, these are all called as column qualifiers. So, and the most important thing is in our Firestore data store also we saw each field you can index it. We saw that feedback example, right, last week, where you saw each field can be indexable. So the use of indexing is it you should be able to quickly search it. You will be able to quickly search it. It's more like your book. At the end of the book you have an index page, right? It is the same thing, so you can quickly search it. But when it comes to big table, right, you have only one indexable field. That is your primary key, or sometimes called as row key. So it's only one field which you can index. So you cannot index first name, last name, all those things. So only one field can be indexed. Now deciding this field is very, very important. If you have something monotonically increasing numbers, you will have the same problem like what we saw in our spanner instance. Spanner also is a horizontally scalable system. Bigtable is also a horizontally scalable system. Wherever you have horizontally scalable system, that hot spotting issue will definitely come into picture. Make sure you design this row key in such a way that hot spotting can be avoided. Maybe you can use some combinations, that is okay, but make sure you don't use it as a time which is increasing, or row number 1 2 3 auto increments. Don't use those kind of a concept, because you will definitely have hot spotting. We have seen what is hot spotting. We are again going to revisit it with respect to Bigtable, where one node should not get hot, should not be doing most of the work. The data should be, write operation should be distributed, and the read operation should be from the same node. That is basically, if you do that, your hot spotting can be avoided. So you will have column families, you will have column qualifiers. Column family is nothing but, in very, very simple terms, a table, folks. Because it's everything is denormalized, you will have multiple column families. You can keep on adding, and because it's a wide column, it's going to be always a easy thing to add more column families. And only one field is indexable. Now, how do I interact? How do I interact with Bigtable? So if it's Spanner, I interact with SQL. If it's my Cloud SQL instance, options like MySQL, Postgres, Microsoft SQL Server, SQL. If it is Firestore or data store, or for example, if it's data store, for example, it's going to be something called as GQL, Google Query Language, which all look like very similar to your SQL. If you know SQL, you would be definitely able to manage with uh, Cloud SQL options, Spanner, or data store easily. But when it comes to data, Bigtable, right? This is where you will really appreciate SQL. This is the way you query the database, folks. Looks very, very odd. There's a question from Vivek. A column family can have multiple column qualifiers. Yes, possible. You can have n number of columns or qualifiers. Basically, a table can have n number of columns, right? So you can have the same thing here. So possible. So one column column family can have n number of column qualifiers, basically. And this is how you create a table, folks. And in normal SQL world, basically, possible, yes, possible, Vivek. So the way we create in a database is create table name, where you mention the the column names and the data type. And to query it, most of us at least have queried the database, because we did a Cloud SQL demo where we did select star from that table. We got it. But when it comes to Bigtable, the way you query it is going to be something like this: scan the table. If you were to insert a data, you are going to do something called as put the table name, the column row key, and the value which you want to do. And there is no update. There's no update in Bigtable. It's always insert. You keep on inserting it. Now you may ask, then if it's insert, then how I'm going to make a difference between when I updated it or not? So that's where you will see a concept called as versioning. Each columns or column qualifiers which you have in Bigtable is going to have a versioning concept. So meaning, first time, if you do this one, put singer, a specific, maybe for example, I started with the name John. Maybe I made a mistake. It has to be Johnny. So what I can do is I can do one more time put command and update it or insert it. So what's going to have? The first name is going to have two values, John and Johnny. After sometimes it's going to do a garbage collection. Only the latest version is going to be kept. So versioning could be sometimes helpful. So maybe if you are updating it continuously at the same value, you can use this versioning to some great extent. stock prices continuously getting changed, you retain the last one, you retain the last value, but you can see how the progress has happened, and you can change this setting if you want. Basically, this versioning feature, you can change it basically. So something very unique which you see is a common column families is one thing which you see as a unique concept, and the columns basically is going to be version. Yes, there's a question.
So Mahesh, for example, if take example of what you said about if the price changes of the stocks, right?
Hmm.
So I have a user interface which I'm showing the latest price, right? But
Hmm.
if every time how so my application has to retrieve the latest version, that is
Your
how my
application,
application will know that.
so So basically what you can do is there are going to be some APIs, Java APIs, and in some other languages you'll have APIs to interact with Bigtable. So when you're querying, you're going to always retrieve the latest. I'll also show you the demo where we will see versioning in action, where if you see, you can get the latest, and if there's any previous versions also, you can get it. So it's basically how you form the query to get the latest one or the older versions. So, and the older versions are going to be garbage collected after some time. So if you don't do anything, by default, it's going to always query the latest one. The default is always query the latest one, but there's a feature called as versioning, which can be sometimes helpful in some specific scenarios. Just to see a minute back, what was the price if you wanted to know, this could be sometimes helpful. And the APIs which comes has that capability to do that. And we'll also show you a small demonstration how you can see the previous version of it. We'll keep on doing put command continuously, and you'll see how it works. And this command which you see, right, this is called as edge-based APIs, folks. Edge-based APIs. So it looks like Greek and Latin, to be very frank, for people with no database background. And even if you have a database background, if you have worked on relational database, this looks little different, little odd, not like your normal SQL world. Create, insert, update, select. It is totally different. It's going to be create, put, scan. That's it. Hope that answers your question, Kumar. And you'll see that when we do the
Yeah.
demonstration.
Yes.
Yeah. So these are two unique features: column family and your column are version. Each cell, usually they call it as cell or sometimes columns. Column qualifier. These are version. And this one, right? I got this from one of the Google Next videos. I guess in 2018 or something. Uh, if you search, you'll get and the Googler explains the big table concept to a great extent actually. So this visual representation was really helpful there. So I just recreated what was mentioned in that video, this one. So this is going to be really helpful. Garbage collection typically is in what frequency? You can set it, Arvind. So you can set that, is what I understand. There is a command where you can set whether you want to collect it very frequently, do a garbage collection very frequently, or less at a specific time. You can do that. There's a setting. I have not explored it, but I have seen once there's a setting there. Now, because it's an horizontally scalable system, even this will also have hotspotting. That's a known truth. But how can you avoid horizontal hotspotting is with a concept called as field promotion, meaning you promote a column to be part of your row key. For example, if this is your design, you have a row key which has memory usage as the row key. A very bad design, memory usage, uh, something like 90% or something like 75% of memory used. If that percentage or something like a number, it's not going to be a good one. So assume it is an app where you wanted to monitor the memory usage. So just having that is not going to be a good fit, because two or three people or millions of people may have the same memory usage uh, using that app if it's installed on your phone. So everybody is going to have the same usage. So this is not a good design itself. Now, to avoid hot spotting, because if you have the same monotonically increasing or similar number, you're going to have basically hotspotting. To avoid that, you promote a column or a field or a cell or column qualifier, all are same, to be part of your row key. Memory usage at this timestamp. So then it makes little better. The combination is going to become better, but still there could be, because millions of users using at the same point timestamp, maybe there are good number of users who's going to have the same usage, or it's going to be very close. Again, hotspotting is going to happen. Looks like something like a monotonically increasing stuff. To avoid that, you use one more field basically called as user, because your user ID and my user ID in an application is going to be always unique. So my user ID is going to be like Mahesh123, your user ID is going to be ABC123. It's going to be always different. So when I use this user ID or a hash or a globally unique identifier, it is going to make my row key very, very unique, which can avoid hotspotting. This can avoid hotspotting. So the field promotions definitely be a good choice, and good amount of time goes in designing the row key itself whenever big table is going to be used. Please keep in mind. So row key is very, very important. Always avoid monotonically increasing numbers, something like 1, 2, 3, 4, 5, 6, or something like a timestamp. 10 o'clock, 10 1, 10 2, 10 3, something like that. Don't have that kind of thing. Have something which is going to make it little unique, something like user ID Mahesh123 plus 10 o'clock 1 minute, something like that. If you make that combination right, all details about Mahesh is going to be written in one specific node. All details about user ABC is going to be written in some other node in Bigtable. So now tomorrow when I want to go and get the details, let me know what was the details about Mahesh. I can just query it. Now when I query it, everything is going to come from one specific node. I can query it faster basically. Or if you take the price, if you take the concept of stock market, you are writing all the stock price about a company into one specific node. Because of this combination, every stock ID or something should be there, right? Some number would be there, or some identification number is there, right? First, every stock price. So stock this thing, so you can use that as an identification number and insert it. So that way write operation is always going to be distributed, read operation is always going to be coming from a same node. So hotspotting will be there in a horizontally scalable system. To avoid that, use your row key, or the design of your schema is always important. So even in our spanner we saw, having your the schema design is always very, very important. So good amount of time is going to be spent here. I guess, did I miss a table? Yeah. Now what we'll do is we will do a small demonstration, folks, where we will see how Bigtable works. And this is going to be little Greek and Latin, so I cannot do anything much here. So there are two ways where you can interact with Bigtable. One is using Apache Edge-based APIs. So if you have used Apache Edge-based, this looks like a cakewalk. But if you have not used it, the commands are going to look like this. Create, put, scan, which is little difficult. So I'm going to avoid that. I'm not going to use Apache Edge base. For first time learners like us, there is another option called as Cloud Bigtable CLI tool, a command line interface using which you can interact with Bigtable. And in reality, people are not going to use this command line interface, folks. They're going to use APIs. To connect, for example, client libraries written in Java, .NET, Python. They are going to use that kind of a stuffs. So no BQ like console. No, you will not have that. You will not have something like a BigQuery kind of a console. We are not seen BigQuery console. It's not going to be a console. So it's going to be everything in terminal, basically in terminal. You just provision it. Any insertion of data, any creation of tables, all those things has to be via either a API, a client library. Like usually Java is a better one for Bigtable, folks, because Apache Edgebase is also written in Java. Other languages also possible, or you use CBT CLI tool. So let me show you how to do this. So go to our console, click on your navigation menu or hamburger menu. So under our databases, you should have that big table option. So database, click on this cloud big table. Yes, Arvind, it's only going to be CLI or via client libraries, or you want to call it as APIs. API is also possible. So this is what it shows. Cloud Big Table is a fully managed wide column NoSQL database that offers low latency. So these are keywords, folks, very, very important. Use Bigtable. To use Bigtable, create an instance and then set up your development environment to access Cloud Bigtable so that you can add data and monitor performance. Let's create an instance. And the moment we create an instance, we'll come to know whether it's a regional resource, zonal resource, all those things. And anyway, we are maintaining a cheat sheet. We'll create that. Now, folks, I did not do anything. I just clicked on create itself. Look at the price. I have not even keyed in anything, folks. I've not even keyed in anything. So this is a product which is going to be very, very expensive. So it falls under the category of your spanner. Spanner is also very expensive. Bigtable is also very expensive. So whenever these two products comes into a project, right, I do little analysis to find can we avoid it. Because even if a small mistake you do, the price is going to be very high. So let me just put this in the implementation cheat sheet. Cloud Spanner and Cloud Bigtable are expensive resource. Just for your information, that's it. So you see, I did not even key in anything. The moment I key in, this number is going to shoot up. It's going to shoot up basically. Let's give a try. So CBT hyphen batch 6. That's my instance name, which is human readable. And I told, right, you are going to have client libraries written in Java or any other language. So in those languages, how you are going to access is basically using this client library. Sorry, using this instance ID. This is the one which you're going to use in your applications. Same as our spanner. Even in spanner, we had a spanner ID. This is what you're going to basically use to connect and do any kind of activity there. Continue. Because it's a storage, you have to mention whether it's going to be SSD, HDD, all those things. So this information can also be asked as a part of your question. So Bigtable is usually used for petabytes of information. And when should I use HDD? When should I use SSD? Those tips, right? If you just read those itself, it's going to help you out. So huge amount of data. And for machine learning, for example, if I just jump back to the concept of machine learning, simple. Forget about those high funda terms like artificial intelligence, machine learning, all those things. Uh, Everybody would have interacted with a child, right? So it may be our own child or your uh, brother or sister's child, somebody, a niece. If you have observed a child, right, the more the data you provide to the child, that the child learns better. For example, if you just give one apple, one orange, and ask the child to distinguish, the child may not be able to do it very well. But if you give 20 such apples, smaller apples, uh, green color apples, or red color apples, and a good set of oranges, 20 samples or 20 set of oranges, 20 set of apples, give it to the child. Now the child would have learned little better compared to the previous one. Only one apple, one orange. So more the sample or more the data you provide, the brain has something called as neural networks. Neurons, to be very specific, sorry, neurons. The neurons are able to connect, and it's going to get a visual picture that, okay, apple means it looks like this, orange means it looks like this. This is how a child builds the knowledge over the period of time. So the brain, the neurons is going to help it. The same concept works in machine learning also, where there is something called as different ways of writing machine learning. One of the popular and the best model usually is written in something called as neural networks. Uh, there also you need more data. So if you need more data, you should have some kind of a storage which can store that petabytes of information. So if you are going to write some machine learning model, you need good amount of data. Storing it in a big table is going to be a good choice. So high latency is going to be high because it's magnetic disk, very traditional one. Good performance on scans and typical use for batch analytics such as machine learning and data mining, where your latency is not a concern. Storing a huge amount of data in a cheaper way is your concern, means HDD is a good choice. So I'm just going to copy this as is because I have seen this kind of a question coming. Don't remember in which exam, but I've seen that. So expensive resource. And you see the difference here between a serverless product and a managed service. Whenever it is serverless, nobody is going to ask you questions like this, whether you want HDD, you want SSD, all those details. You just load the data like our Firestore or our Fire data store or our Google Cloud Storage. But whenever it is going to be managed, like your Spanner, Cloud SQL instance, big table, it's going to ask this n number of questions. Setup itself is going to take some time for you to decide. But if it's serverless, very easy. Just load the data, start working on it. So big table, use storage for machine learning. Data mining, cheaper. Similarly, the SSD option, when should you use? Basically, wherever you have a high input output operation requirement, SSD. What is that used for? Basically, whenever you need a low latency um, requirement, something like IoT or recommendation kind of a stuff, or in financial sector, not from the transaction perspective but more on the analytics perspective, SSD is going to be a good choice. So recommendation, cheaper, high latency. Expensive, low latency. So for recommendation, IoT analytics. So that's where we are going to use this. So let's go with SSD for now, or we can use HDD also. And anyway, it is build per hour, folks. Does not make any difference. So we are going to finish the demo in an hour, basically. So more like your spanner. So I'm going to go with HDD, and we are just going to see how we can interact, basically. We're not going to do anything more there. So configure the first cluster. So you give a cluster ID. So here is going to be basically a big table is going to be a zonal resource. Singapore, I select a specific zone. It's a zonal resource. Simple. So you can add n number of clusters, replicated clusters, if you want a better throughput. But basically, it is nothing but a zonal uh, resource. Let me also add it in my cheat sheet. The only reason why I'm jumping from screens to screen is just to keep track. Otherwise, we will lose it basically. So as you do it, you add it. So it's going to be a zonal resource. Simple. Big table, zonal. All other stuffs is going to be no, but you can have multiple If I just go back, I'll just show you that. One node, based on node only, you're going to be charged. So one node, if you want, good. In a production, usually they prefer to use 3 nodes. If I put 3 node, look at the price, folks. Look at the price. And if I use US Central, which is going to be the cheapest one, if I use, it's going to be $1,400 or something. $1,400. So now, how do I protect against zonal failure? So that's where you are going to have something like this.
So Mahesh, whether you store the data in these tables or not. For example, I created in production, but I'm not using much for this table, but I still need to pay this amount, right?
Yes. It is like your disk, your persistent disk which you use. Whether you use it,
Yeah.
the moment I click on create, you should pay this per month unless you delete it. Unless you delete it.
Okay, thank you.
So yeah. So how do I avoid zonal outage? Basically, what you do is you mention a specific zone. For example, let me say take Singapore. Singapore, I'll take A zone. Now, if you want to, what happens if this zone has an outage? Basically, you create a replication. You create a replication. So add additional cluster to this instance to automatically replicate the data between them. So meaning I already have it in Singapore A. Now, if I want to have one more cluster, what I'll do is cluster 2. In if I select Singapore itself, because the data needs to be in Singapore, what I can do is, you see A zone is grayed out because that's the main cluster. So you can have it in basically another zone. This is how you can basically avoid a zonal outage if you feel. Now, if you feel no, zonal is not okay, I'm not sure whether this is going to be a good choice. I wanted it in a different region altogether. You can do that also. So you can do also that. Say, for example, you want to use Taiwan. You can use Taiwan. You can choose any Taiwan region, zone. This is where you can do it. So you can add clusters, replication clusters in multiple zones. In multiple zones, each cluster is going to add up to your cost. So I assume the access or the endpoint URL does not change. No, it's the same thing. It's the same thing. It's the same thing which you are going to. So just having more replication. It's the same thing. So now you see it is going to be plus. What was the main cost? It is plus because you are adding a replication. So your cost is going to double up. Whenever you add replication, it's going to double up basically. So you can have it.
My
Yeah.
sorry, because if it is regional, then why you're saying it's a zone actually? Because you can select region and zone, right? And you can select different
No.
region as well.
Okay. See, at the end, the cluster resides in a zone only, right? So if I mention any, it could be in any of the zone, but the cluster runs in a specific zone only. It is not a regional resource. For example, if you see Google Cloud Storage, can you run it in a zone? You cannot even provision. It's going to be always regional. The scope is
Okay.
always regional. So here, the lowest one is always your zone. In your Google Cloud Storage, the lowest one is a region or dual region or multi-region. Your virtual machine, the lowest is always a zone. So,
Okay.
and the reason why you select a region is to get the zone details. Or they could have had a user interface like avoid this region totally, just all
Yeah.
have all those 73 zones. It's going to be a little difficult for you to navigate and put it.
Okay.
That
Okay.
is the reason. Yeah.
Got it. Got it. Thank you. Thank you. Sorry.
Yeah.
Sorry about that. Yeah.
Will Google auto promote the replica instance as master if the original master goes down? So this is not the same style like your Cloud SQL instance where it's going to basically uh, do promotion. So this is going to be automatically replicated. So it's going to manage it automatically. There's no promotion or something which is going to be done because the data is already replicated. So data is replicated automatically. So it's going to be automatic. So you don't need to worry much there, but there's no concept of promotion or anything like what you see in Cloud SQL. That concept is not there here. So because it's already replicated. Can I have a number of replicas? Can I have n number of replicas? As long as you have enough budget, Mangesh, you can add n number of clusters. Now I have one in Taiwan. Now you want to add one more in London, add it. So you can add how much is your budget, you can add it. But it's always going to be in a zone. Please remember it. Now I have one more cluster, cluster 3 in London A zone. Now it's going to add to my this thing. So now I have 2 replication clusters. Now you want to have one more in US Central, go for it. Go for it. Cluster 4, you can have it. So this one is going to be an expensive product. So be very cautious where you want it to be running. It's always going to be in a specific zone. And I assume the replica needs to be the same storage. Basically, yes, it has to be what is your main cluster storage. It's going to be the same thing. Same thing. One cannot be SSD, other cannot be HDD. It has to be the same. So that's it. So my cost is going to be 2000. Basically, if you add more replicas, it's basically a zonal, but you can have multiple replications. So I can create something like, where should I put that? Multi-zone is what it's going to be basically, or I'll put it in comment section. Replicas, replication in multiple zones, zones in multiple regions is possible. So this is possible. This is something which is possible. Now I will not create this much so much heavy cluster. I'm just going to delete those replication, which is going to bring my cost back to 500 US dollars. Now what I'll create is I'll just click on create, and it's going to be created super fast. We should have the cluster running so super fast. Basically, that's it. The cluster is there. It's a one node cluster, and you want to add more nodes to make a better throughput, increase your throughput, and have to handle more data. You can easily add more nodes. So if I just go edit the instance, this is the cluster. So you change the node. That's it. You can easily add a node whenever you need, basically. But it's not auto scale, so you have to go add it. So you have to have some kind of a mechanism where you can go increase the number of nodes based on your requirement. Can I change the region after creating without dropping the table? No, you cannot change the region or the zone. So if I click on this, you see basically on the existing cluster, these are read-only fields now. I cannot change it. I can only increase the number of nodes. I can only increase the number of nodes. But if you want it in another region, basically what you should do is add a cluster, add a new cluster in a different region. If you have made a mistake, you can add a new cluster or import export, that kind of an option. But the zone, once you fix it, it's not going to be changed. It's not going to be fixed. Is this spinning up VMs in the backend? It's a managed service. At the end, it's going to be some kind of a compute option, but it's not going to be exactly VMs, Arvind. So it's not going to be exactly VMs, and you cannot also see it. So when we create Dataproc, we have not looked into Dataproc, which is a big a Hadoop instance. When we create that, you will see the VMs in our GCP page itself. But here, it's going to be a managed service. We'll not know where it is exactly getting, like whether it's going to be provisioned as a simple virtual machine or something else. Basically, it's a managed service. So even if I go to my compute engine page, you'll not see anything. You'll not see anything. But later when we do something in our big table class, right, big data class, big data, you will see something will be created automatically. So it's not something which we can see. It's basically managed. So now let me just go back to my big table and try to connect and insert some data. Okay, so create a table and insert some data. Now for doing this, I have to use cloud. There's no option, folks. So if you click on that in the user interface, the options which you see is tables. If I click on tables, there's no option for me to create a table. Like how you got, at least in your spanner, there was a user interface to create a table. Here, nothing is there. So you have to do everything via edge-based API or CBT CLI command or using a client library. Or the last option is using a API, REST API. So I cannot do anything. So what I will do is I'll launch my Cloud Shell. So I'll launch my Cloud Shell and do all the stuffs in this. So the most important component which is required for this is called as CBT, is the utility which you are going to use. Now whether this is installed or not, if you want to verify it, you can use this command gcloud components. Mostly in your local machine, the cloud SDK, it may not be installed, but in Cloud Shell it's going to be installed. So if you run gcloud components list, it is going to show the list of components which is installed. So if I slightly zoom this out, um, you will see Cloud Big Table. This one, Cloud Big Table command line is installed. So it comes installed by default. So you don't need to install this. Now, if on your local machine, which is your laptop, your MacBook, if it's not installed, the way you are going to install it is gcloud components install CBT. If you do it, it's going to install it, basically. Okay. So since it is already installed, I'm not going to install it one more time. I'm just going to use this command. So there's a couple of commands and all this commands, right? This looks little weird. So I have already captured it in the cheat sheet. So what I'm going to follow is what is mentioned here, folks. No difference. It's going to be the same thing which I'm going to follow. The first thing which I'm going to, there is something called as emulator. So basically, if developers are working, right, they don't want to create some instance just for testing purpose or just for development purpose. So that's where they use emulators, basically. So they use emulators basically. So you get emulators for various such tools. Bigtable also has an emulator. So you're not going to get heavily charged there. So it's going to be something like a software kind of a stuff, Vivek, to preview. Yes. So let me create this one. So there's some couple of commands where I have to do this. So if I do ls minus a, I don't see a file called as .cbt rc file. So there's no such file like that. So we need to create a file. So I'm going to create something like echo project dev shell underscore project ID. So I will write this information into my home directory and in a file called as .cbt rc file. So which is going to keep the details about my project ID. So I'm going to write it. Done. Then I also need to add one more information about the instance ID. I told, right, this is how you are going to copy or access everything. So instance, what is the instance ID which I have? Overview. This is my instance ID, CBT batch 6. CBT, okay, Arvind, so that's your environment variable. So that's your environment variable which holds your project ID, only available in Cloud Shell. CBT batch 6. CBT batch 6 was my instance ID, if I'm not wrong. Yes, that's my this thing. Now, please append this. Please append this to the same file which we have. That's it. So now to content is what we have written. So if you are interested, just go look into that CBT file. You should see the two stuffs. Now, this is what basically your CBT utility expects to use. So that's the reason we have populated with it. Now, if I do CBT Cloud Bigtable, the CLI tool, which is written in Go language, if I put ls, it does not list anything. ls basically list any tables in your Bigtable cluster. Nothing is there is what it indicates. Now, how do I create a table? So it's going to be CBT create table singer. Now the table is created, folks. Now you rerun the command, list all the tables. It's going to show you singer. Good. Now, once the table is created, you create a column family, CF. So let me create a column family, two column families. Create column family. I'll call it as in which table? Singer table. And what is the name of your column family? Personal underscore CF. Now, it is not mandatory that you put underscore CF, folks. This is basically whatever you want to put as per the naming convention. But why I'm putting CF is just for us to understand this is a column family, because this is slightly a new table concept which not most of us would have explored. So using the CF is going to help us to understand, oh, this is column family, this is column qualifier. That's the reason. So I have one table, sorry, one column family created. Let me create one more column family, something called as album. Done. So CBT ls, if I do, it's going to just show me the table. But if I do CBT ls singer, it's going to show me the details. It's going to show me the details about the column family this table is going to have. And somebody had a question about the garbage collection policy. You see this, it has never been collected. So you can set this policy, garbage collection policy, based on your requirement. Uh, uh, there is one question. Unless the question is confident, is it possible for all the students to ping their questions under everyone? If I do, you can. Okay, if you want to share anything, Arvind, which is going to be helpful to every learners, you can put it in your everyone. If you feel there's something which is a unique question which you have, you can put it into your basically into your the private one which only comes to me. Uh, yeah. So now I have a table. I have two column families. Now what I'm going to do basically is I'm going to insert the data. So using CBT, the way I'm going to insert is going to be in this fashion, folks. CBT set singer. You have to mention a basically a what, a row key. Row key better to have, which is going to be something like an hash or a globally unique identifier. So I'm going to use this GUID generator, online generator. So where it's going to generate an ID for me. So generate some GUID. Got this. This is my ID, and I'm going to put hyphen John. So nowhere I can create an hotspotting here. I'm going to create the columns, folks. Just hold on. So I'll show you how to create the column families. So I'll show you that part. So basically we have the row key. Now you mention in which column family you want to create a qualifier, the column qualifier. So I want to add a column or personal underscore CF. Inside this column family, create me a field, a column, a cell, a column qualifier called as first name, John. First name like John. That's it. This is how I add a new column family. Hit enter. Done. I have written the data. Now, if for the same thing you want to add a last name, you do it like this. Last name Johnson. What do you mean by the first name? The first name is the column name. If you see what was there in our slide, we had that, right? The column. So you created a column qualifier called personal information. So first name is the column name. John is the value. John is nothing but the value. Yes, it is a value. One, I would say one cell is value selected, created, basically. Now you want to create the last name. Let me create it something like Peter. Peter. So I have created it. Now, if I just go to the demo back. So I have created basically one row. Now for the same details, right? If I want to add album details, what I do is I have it in my album qualifier. So where I'm going to give a name, something like album name. I'll call it as album. Something like rock, 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 and it's going to insert it. Now what I have done, basically I have inserted a data. Now let's just read it and see how it looks like. CBT read, which has two column qualifiers. Each column qualifiers at least have, sorry, each two column families have at least one column qualifier so far. If I just have read this, this is how it shows me, folks. This is one row. In that row, I have two column qualifiers. One is personal two column families. One is called as personal column family and the other one is album column family. So in album column family, I have one qualifier or one row, column called as album. In my personal column family, I have two column qualifier or two cells or two columns or two fields called as first name and last name. So syntax is like that, basically, Arvind. So you have to give equal to, then you do it, or you have to stop at a column. So you have to give the syntax. The syntax is the album name. The value is going to be equal to the value. To avoid hotspotting, you have to have a random big name. Basically, it's not that random big name, as long as it can be unique and it's not monotonously increasing, Vivek, it should be all good. It should be all good. So I wanted to insist on using a GUID or a hash, which is definitely going to avoid any such thing, basically. Even Mahesh, if you put, or John, if you put, that is also okay. But the John is something everybody is going to have. Having John ID, the ID of the user is going to be a better one. So now I have the stuff. Let me create one more row, folks. So I'm just going to generate one more copy. Now for this one, right? Because we know the tables in big table is PaaS. For this one, right? I will not have a last name itself. The next row which I'm going to do, I'm not going to have a last name itself. I'll only have first name. So GUID is globally unique, Arvind. So timestamp, I can have two people information instead of the same timestamp. If I use that, both the information is going to be written into the same node, So there's a chance that many people, if you see the entire world, so some people assume this is a system where people, you want to log who is logging into the system. So at a given point of time, millions of users log in at the same timestamp, you will have issue. But if you have a unique identifier, a globally unique identifier, it's going to avoid hotspotting, basically. Okay. So John, I'll call this as William. Definitely, it's going to be high. So I'll just mention this as William.
Mahesh, do we need to give always the qualifiers? Can
Yes. No, without qualifier, how will you insert it? So because you are mentioning, sorry, family or qualifier you are saying?
I mean,
You have to
uh,
mention both. You have to mention both.
okay, we need to mention both. Okay.
Yeah, the column family, and inside that column family, what is your this thing? So you have to mention it. Now I have the data inserted. Now I will only have the album details. The last name is going to be empty. I'm not going to mention it. So it's going to be sparse. It's not going to take space. So album name, done. Now there's a question which Arvind is asking, what if the column name is not at all there? So what if the column name is not at all there? So it is going to create it. That's the beauty of NoSQL database, basically. So if I just do CBT, read Singer, first I'll show you what is there. You should have two rows. This is how you see. So in the first row, which is about John, there is an album name, first name, last name. Second row, which is about William, there's only album name and first name. Now, if I do add a new column only to William called as when this was published. When was this published? So something like the year of publishing this stuff. Done. This column was not at all there. Now I have inserted it. Now what's going to happen? If I read this, only for William, you are going to see the year of publish, when this album was published. It's going to create it. That's the beauty. So on the fly, the column is going to be created. This is where the NoSQL database really rocks compared to your relational database. Okay. Hope that answers your question, Arvind. So now what I wanted to show you is the concept of versioning. Uh, uh, Concept of versioning. Now, I made a mistake having the first name of William, as it's not William, it has to be Will. So what I'm going to do is again going to run it. I made it as Will. First, second update I have done it. From William, I have made it as Will. One more time, what I'm going to do is again they come back. It's not Will, it is uh, Will Smith. Let me just put this. Second, third time I'm updating it. Now I have totally done 3 times of updates. Now if I go read this, you will see true versioning in action there. You'll see true versioning. You see this timestamp wise at and this is in UTC time format. It is in UTC time format. 148. You see it was William. 150 it was Will, and 150 it is Will Smith. So it keeps a track of the time and it is version. Now after sometimes it's going to do a garbage collection and it's going to be always Will Smith is what is going to be a final row. So just a recap, you use GUID once, and for every subsequent instance you because I'm going to insert that to the same row ID, right? So if I want to do any update to William, I will use that same key. So that's my primary key or my row key. That's what I'm going to use. Now you get a concept of versioning, folks. This is the versioning concept basically. So you can keep this thing, and uh, at once the garbage collection happens, I'm not sure what is the frequency, but there's a possibility of setting it. Once the garbage collection happens, it's going to be left with only Will Smith basically. So these are something which I wanted to show, and it is a very high level demo, folks, and it's not something which we are going to spend more time. So uh, deciding the product, deciding the row key is something which we can give as a thought when a design process is going on. Remaining everything, interacting via a client, what client to use, whether it should be in Java or some other language, it's going to be decided totally by a application lead or an application architect who's going to write it. So we have basically CBT LS, we have a table, we saw how we read it, and it was totally different. So now only your respect for your clouds, your SQL language will increase. It was so difficult, right? CBT in CBT get, sorry, CBT set, CBT ls, CBT create family. So it was so weird. But in SQL it was so easy, only because we have at least seen it once there. So it was easy. But here it is little difficult. So you now see the value why a database being ANSI SQL compliant makes most sense. So if it is out of scope, please skip this question. How do you visualize the hotspotting? Is there any service within GCP? Good question. So you can see hotspotting if you wanted to see. Now if I click on this table, sorry, instance, click on tables, you see the table. So now it shows the table is created. Let me just zoom. The table is created, the status is ready, utilization is very small, so it's showing as 0 bytes. You can take a backup of your table if you want. Now if I want to see whether the hotspotting is happening or not, you have a visualization called as key visualizer. So called as key visualizer. If you click on this, you're going to get you select the table. Currently it's not even eligible, so you should have good amount of data for it to scan and show whether hotspotting is happening or not. So it's going to show you that part whether the issue is there with this table or not. So there is a visualizer in your big table itself called as key visualizer, but you should have good amount of data. And whenever it comes to big table, right, there's a rule of thumb which we use called as don't use big table if the data is less than 1 TB, folks. This is a rule of thumb. The reason is behind the scene, big table does some kind of a self optimization by itself. So I mentioned, right, low latency, all those things. The moment you load the data, you cannot expect that. So you have to leave the system to self optimize, learn the patterns, and after 2 hours or 3 hours is what it's going to give you the expected output. There's some kind of a machine learning behind the scene. So for machine learning to work, good amount of data is required. So please don't use it if it's less than 1 TB. If it is less than 1 TB, something like 500 MB is what you're going to have, use Firestore or Data Store. There's alternative NoSQL database available. So better use that. Or if you don't like them, use something like Cassandra, MongoDB, something like that. But don't use big table for a lesser volume. The same example like Spanner versus Cloud SQL. Cloud SQL is your budget car, Spanner is your posh car. Similarly, Firestore is going to be your budget car, Bigtable is going to be your posh car. So don't use it for small things. Only if there's a requirement like this low latency requirement, then go for it. The main reason is first, the product is expensive. The second thing is if you use this also, you're not going to see the value out of it. Small data, it's not going to work very well. I have seen such systems like this in my experience. More the data you provide, the system is going to be much better. It's going to act very well because most of the time such systems have some machine learning capability built in. This is something which you need to keep in mind. And the reason why it is not showing us this table is not even eligible is basically amount of data which you inserted is peanuts, not even peanuts, lesser than peanuts. Two rows only you inserted and with only two column families or something. So it's very, very less. That's the reason it's not even eligible. So not supporting and not supporting relational database. What was that, Mangesh? Did not understand. I have a screenshot saved somewhere about this key visualizer. I remember seeing it in some article. I had taken a screenshot of it. Maybe tomorrow I can share you that, folks, how it looks like visualize the key visualizer. Okay, so this is a rule of thumb. Keep in mind. Let me delete the cluster now and take a break. Once we come back, we will do a small comparison because when to use Bigtable, when not to use Bigtable could be a question. So we'll just have a clarification on that. So I'm just going to delete the cluster and Kubernetes, Bigtable and Spanner. Whenever you do it, please be sure that you remove it once you finish it. Otherwise, it's going to exhaust your free credit quickly. I'm just going to delete this. No more clusters. So now we'll stop it here. Once we come back, we will see a difference between Bigtable and data store. We'll see a difference so that it's going to give you some good idea when to use what and when to avoid which one. Okay, so take a 10 minutes break. Uh, take a 10 minutes break. Thank you, Arvind. There's my timer. Take a 10 minutes break and come back, folks. Let me stop the recording.
This conference will now be recorded.
So before the break, we saw a small basic demonstration of Bigtable, and we also saw how the versioning works, how you insert it, and it was basically Greek and Latin is what I would say, because it's not something very user friendly. I would say something like that because the SQL statement, every NoSQL database will have this problem, folks. Now tomorrow, if you go to MongoDB and do some querying, it's going to be totally different. You go to Cassandra DB, Cassandra, Apache Cassandra, it's going to be totally different. Neo4j, it's going to be totally different. So every NoSQL database will have their own querying language, which is one of the big drawbacks when it is learning for an individual. But when it comes to relational database, you learn SQL, structured query language. I would say 60 to 70% you would be able to interact with any database, MySQL, Oracle, Postgres, IBM DB2, anything. That's the key part with that SQL language itself. Now, we have seen two NoSQL database, data store, which is totally serverless, and a managed version called as Bigtable. So both are NoSQL database. Then when should you use what? Basically, so first difference is the index key wise. In data store, you can have multiple index keys. This is one way it is going to achieve the fastness for retrieving something. When it comes to Bigtable, only one key or one field can be indexable. That is called as your row key. That's one important thing. When should you use Bigtable? Whenever you're going to scan sequential data. Get me all the details about Google's stock price for the last 3 years. It's a sequential scanning of all Google related stuffs. That's where you're going to see Bigtable shine. But if you say, get me all the stock prices of all the multinational company for the last 3 years where the stock price was XYZ. If you put this kind of a stuff, you are doing a non-sequential keys. Basically, it can show Google, Azure, AWS, lot other stuff of the MNC companies where the stock prices was between this range to this range. You can do that kind of stuff very easily with data store. Usually they use a small analogy for data store. Data store is something like searching a needle in a haystack. If you were to search, it's going to be so difficult. So that kind of a search, data store works very well because you would have indexed each and every field. So it's going to be super fast there. But whenever it is sequential scanning, big table really shines there. The third difference, it's a managed service. You have to decide where the cluster should be provisioned, how many replications you need, what is the kind of storage, how many nodes you need. You have to mention every details. But when it comes to big data store, nothing like that. You only need to decide the region. Finished. No storage type to be mentioned. No need to mention how many replicas you want to keep. How do I take a backup? Everything is fully going to be managed by the cloud provider. It's totally serverless. It can scale up very easily. When you want to scale up your big table, you have to go add nodes manually. There's no automated way. So you have to go, maybe you can have a script built, but you have to build something. But when it comes to data store or Firestore, as the more data gets inserted, the system scales up easily. That's the beauty of serverless. And when to use data store, when to use big table, if your volume is less than 1 TB, prefer to use data store, or it's in few TBs, use data store. If the volume is less than a TB, don't even use big table. Don't even think of big table because it's not going to give you the return on investment there, and it's going to be expensive. Plus, it's not going to work as expected. Don't raise a support ticket saying that in the documentation I saw it was all something like 6 milliseconds or 10 less low milliseconds, but when I load the data, it's not coming up because the volume is very less. So if you load something like 500 GB and expect something like that, it's not going to happen because the pattern, all those things is not going to be better if you have lesser data. Okay, so the last one is it's a zonal one. Your data store or Firestore is multi-regional or regional one. So there's one question, couple of questions. In the existing CBT cluster space can be that you can increase it. That you can increase it. So add more nodes basically. So you can increase that basically. That is possible. Is Bigtable a columnar data store? Yes, is my understanding, Arvind. So it is also a columnar data store only. Wide columnar data store. Wide columnar data store. So that's a small comparison which I wanted to give basically. Are you going to talk about backups? Backups of Bigtable. I just showed you at a very high level. There's a table. You can just click on backup. So uh, that way you should be able to back up the stuffs. Maybe if you want, I can just recreate the demo quickly. So I create instance CBT batch 6, continue. I'll come to that. So I created in Singapore one node is what I'm going to say. So in this one node, right, how much data you're going to dump basically, you can say so that you will get a complete picture. So if I mention like 1 TB, this is going to be my storage cost. I guess Vivek was asking this part. So you can get an idea what is going to be your storage price. So create a Bigtable instance. Create a Bigtable instance. There's no table. Let me quickly create a table. So if I just click on this, I will not see any tables. It's an empty cluster. So let me quickly create a table and insert a couple of rows. Now, if I use, oh, sorry, reject it. I'll just create a new tab. No problem, Arvind, because new cloud architect version is going to come. Who knows? They may ask you questions on backup also. Just being aware of that is going to be good enough. So if I do CBT create table, Singer is the table which I wanted to create. And I'll create a column family CBT, sorry. CBT create family. For some reason, the control keys are not working properly. 1 minute. Control R, CBT. Okay. Create family, Singer. It's not even working. No worries. Personal CF. What is happening? Sorry. Let me just create it. Create family, Singer, personal CF. I'll just use this information to insert data, folks. CBT ls Singer or read Singer. I have a table with some column family and also have a qualifier. Now, how do I do basically the backup? So if I go to the tables, I see a table. You have this option. You can see create backup. So if you click on create backup, you can mention how you want to, and maximum is, I guess, 30 days if I'm not wrong. You can keep your backup for any amount of time between 6 hours to 30 days from its creation date and restore it at the time before it expires. After 30 days, it's going to automatically expire, is the option here. No, actually the history, Arvind, when you do in two shells, it does not work very well. So it's a cloud shell, so it has its own limitations. So that's the reason it did not work. Uh, so you can take backup. You can keep the backup for any amount of day. Maximum is 30 days. Maximum is 30 days. So it's going to expire on 26th of April. So if I create this backup, so Singer backup, BK. This is how you can do a table level backup. Now, if you were to schedule this, basically, you have to write a code. You have to write a code. So if I click on create backup, it's always going to ask the table, the cluster ID, and you take a backup. Now, if this part you want to schedule it, do all those things, basically, there are few components which is available in GCP, like scheduler, which we have not even talked about it yet. So maybe when time comes we can talk about it, called as cloud scheduler. But the problem with cloud scheduler is whatever you write, it cannot be a shell script. Usually when we think of schedule jobs, we think of a shell script, right? A cron tab, that kind of a stuff. When you are using cloud scheduler, it cannot be a shell script, a Linux script which cannot there. So basically it has to be a web-based one. So you have to either use a cloud functions or app engine, some kind of a web-based application which calls the big table API, calls this everything via the APIs or using your client libraries. Once you have it, then you can go use your scheduler. So because the scheduler is always web-based, uh, something like something like that. That's going to be the one. So have your code in your scheduler. Have the code in cloud functions because you want to run once in a day based on a trigger, right? So you can have a cloud functions which is going to be HTTP trigger. Call this maybe at 10 o'clock in the night. Uh, Configure that in your scheduler. That's going to call this, and the backup is going to happen. But the backup can be retained only till 30 days, specifically in big table. That is the limitation. Okay. Uh, so now if I were to go ahead, what's the question?
Hi, Mahesh. Can you hear me?
Yeah, I can.
Yeah, great session so far. So, the next question was, yeah, thank you for answering the backup. That answered my question. And you don't have to do a demo for my next question. I just want to understand how does access control work for CBT, in the sense that can you have access set up for specific tables, or maybe even specific tables, and then also specific column family, if that was the right word. Reason is, for example, in in some of our
BigQuery you have
use
it.
cases,
Yeah, go ahead.
we have like highly confidential data, and the highly confidential data, the way it works is, if let's say the table has 5 columns, 3 columns will have non-confidential data, and 2 columns will have highly confidential data. And sometimes we have requirements which says, oh, these people cannot access the last 2 columns, but they can access the first 3 columns, something like that. Is that
Column
possible
level
in
thing.
CBT? Yeah.
Column level thing. So first of all, to give the access, first and the foremost thing, if somebody needs to get access to CBT, it's going to be basically using IAM role. You give them the specific IAM role, cloud big table. So if I just search big, uh, so you have these roles, big table, reader, user. The lowest one is user or reader. If I take big table user role, what's going to happen here is you're going to read the table details, rows, all those things. Basically, read and write access to an existing table, read access to metadata for this thing. Okay. User is going to have that. If I go with reader, big table reader.
Yeah, but this is going to be across all at a cluster level,
I'll
correct?
come to that. I'll come to
Yeah,
that. I'll come to that.
sure.
Yeah. So when it is a big table reader, you're going to have only access to read the tables, all those things. So this is, if you give it at a project level, this kind of an access, you are going to give basically a specific user access to it. This is at a project level. So if there are 2 clusters, 3 clusters, everything you will have access to. Now, to give it at a cluster level, only to one cluster. So first let's go from project, cluster, then to table, then to a column. So that is the hierarchy I'm trying to show you. So if you go to big table, so assume there are 2 clusters. Okay. Now I wanted to give one person only access to this cluster. Then what I will do is I'll use this show info panel and give that person access only to this cluster. Only if there are 10 clusters in my project, only to one cluster I'm going to give access, nothing else. Something like this, and you give what role you want to give to him. We just give this. So this is something at a cluster level you give. Now coming to the next thing, which is a question is, can I give access to only to a table or inside a table if I want to give only to a specific column qualifier or to a specific column family, to the entire column family? That part I have to check it. Per my understanding is currently is no. I may be wrong. My understanding is it is you cannot give, but I'll check it and let you know. The specific but in BigQuery, which we have not even covered yet, it's in our big data module. You can do column level access. You can give it. That's a feature which they have given now. So you can give it at a column level. To answer Arvind's question, if you have your data in BigQuery, assuming it is in BigQuery, and there is 10 columns, you can give only one column should be visible to everybody. Remaining 9 column is confidential, only to a specific set of people you can have it. That is what you can do in BigQuery. In Bigtable, I'm not very sure. My understanding is you cannot give, is my understanding. So I'll get back to you on that, Arvind. So, but table, so something like all the clusters, specific cluster with IAM, it is possible.
Understood. Thanks, Mahesh.
Yeah, in BigQuery it is possible. When we do BigQuery, I can show that in BigQuery it is possible.
Yeah, BigQuery, I know it is. We use BigQuery in our current project. And that's why I was asking the question, because we have that use case currently. And I was wondering if we start using.
Yeah, no, I would say if you're already using BigQuery, I would say not to use Bigtable if you don't have any latency issues. Because Bigtable, right, is a NoSQL database. You cannot connect to any BI tool. If you have Tableau, Click, or anything. If you're using a warehouse like BigQuery, Teradata, Netezza, those kind of stuffs, right, you can easily connect to a BI tool. Standard BI tools will support it. So it's going to be more user friendly. It's going to be your SQL. It's not like the one which we saw. But only if you have a specific requirement which is low latency. It's like Bigtable and BigQuery both are going to go hand in hand. Only when the latency requirement comes, Bigtable shines very well. If there's no latency requirement and if it is the number of columns are less, all those things, BigQuery shines very well there. And it is serverless. It is serverless. It's not like this super expensive like Bigtable. So, and not sure whether you people saw the article. BigQuery was given as the best product by Gartner. There is some criterias. 5 out of 5 they got it, beating your AWS, Azure data warehouses. So BigQuery is now the best one, at least as per Gartner report 2021. So that's a good one, I would say.
So Mahesh, if you can, I mean, what is like a real life example where some client or some company has used Bigtable? Like I'm trying to understand in what circumstance. Is it primarily for IoT?
YouTube. Your YouTube is using Bigtable. So when you give your what is that? Your comments, and when you're playing the video, and if it's a 1 hour video, if you just stop it at the 30th minute video or 30th minute, and 2 days later you come back, it will show you, right? You saw till 30 minutes. You want to resume back. Your recommendation options, all those things. These are all driven by basically Bigtable. So Bigtable is being used heavily by Google itself. So apart from Google, any other customers using, basically it's going to be heavily for IoT. Any organizations, we have to see the customer base. I have not seen people specifically using Bigtable. So looking into the customer success stories, we can get it. But Google, they themselves use this very heavily. They themselves use it heavily.
Clear. Thank you, Mahesh.
Yeah. So let me just show one last thing. How can I increase the storage? Which was one of the questions from Vivek. Edit. So size. So if you want to add more size, you add it, Vivek. So it's an existing cluster. You add more size, save it. You save it and do it.
So the storage doesn't auto scale, right?
No. There's no auto scaling feature in Bigtable. Make it very clear. No auto scaling. So you have to go. Maybe you can automate it with the help of some cloud functions with cloud monitoring, all those things, but there's nothing like inbuilt which comes. Maybe in future they may bring it. For example, some products have seen which was not there, auto scaling was not there, they have brought it. Like in Hadoop, Dataproc, they have that auto scaling feature, which was not there 2 years or 3 years back. Now they have brought it. Maybe they may bring it in the future. All right, so let me just delete the cluster.
So basically, then you need to have like a good alerting monitoring system for this, right?
Correct. That's where we'll look into. Okay, I have to delete the backup. This is a new thing. Good. I never took backup actually. Only for your batch I took the backup. So delete the backup. Only if you delete the backup, you can remove the cluster. Is what is the condition? Makes sense, right? So how can you have a backup without a cluster? So now I can go ahead and delete my instance. Now the cluster should get deleted, and my billing is per hour billing, folks. Maybe 50 minutes we ran, so we are going to be still charged for 10 minutes more because it's per hour billing in for big table and spanner. Now we'll go back. This is where we stopped. So that's something on the big table, so the NoSQL database. Now so far which we explored is basically Cloud SQL, first Google Cloud Storage, Cloud SQL, Spanner, Firestore, Data Store, and Bigtable. All the storage options, right? If you see, one commonality between all of them is the data gets stored on a disk basically. But when it comes to a requirement where you don't want to call, because reading from a disk is always going to be, there's going to be a latency. But if I can read it from memory, RAM, random access memory, it's going to be super fast. Nobody can beat reading a data from memory. And that's the reason many of the apps they load the data into memory so that it can be rendered faster or retrieved faster. So if you have a requirement, say for example, a e-commerce website itself, the moment you log in, for example, Amazon, the moment you log in into Amazon, certain information should be automatically loaded, meaning what was your past history, how many orders you had done, what is your home address, what's your preferred credit card or the payment option. So all those options, if you were to load it like once the session is started, what people usually do is, maybe for example, assume the database uses Spanner or MySQL instance. First time when the user logs in, it is successful. The moment the login is successful, what usually the application development team can do is they can read the data from the database one time, select star from customers where user ID equal to Mahesh. You get all the details where what was the order I did, all the history, everything is going to be loaded into a memory. And till my session gets timed out, I can read it from my memory. So maybe I would have seen, I have done myself, what was the past, say for example, if it's a glossary item, so I go back to my history, see that, and order it again. So every time if I hit my backend system, which is my database, it's going to be a overkill, and I'm loading my system again and again. Instead of that, keep it in memory so that your access is going to be faster. So that is where products like Redis comes into picture. There are lots of in-memory database available. One of the popular one is Redis. The other one which you have is called as Memcached. Both are open source. So if your application is already using Redis in on-premise or in any other cloud, you can also easily do a lift and shift to a product called as Memory Store. This is a managed version of Redis. So the whole advantage is your application data, you cache it. You cache it here, and whenever you want, your application reads it from Memory Store rather than hitting a query to your database. So this way, the latency can be improved to a great extent. So there are two products which Google offers under this memory store. One is Redis, and the other one is memcached basically. And if you have any migration requirement, you can use it. Now, I have seen people using Redis very heavily. The reason is they want to cache things, have a better user experience. So in this case, it comes very, very handy. And just for your information, Redis is a NoSQL database, basically. So it's NoSQL in nature. Whatever you store, everything is going to be in memory. Let's see a small demonstration of how this Redis works. And we are not going to do querying and all. That's not a piece of cake here. But what we are going to do is basically, how do you provision it? What are the important stuffs as an architect you should be focusing on? And there's one specific thing which you need to be aware with respect to Redis, or basically memory store, how developers can access it. So is there a method where the developers can access it? So that is what we are going to see basically. So let's see. And this is fully managed. You don't need to worry about installing it or anything. So it's more like your Cloud SQL instance. Basically, it gets installed on a virtual machine. So a virtual machine will be there. On top of that, Redis or memory cache will be installed. Then you will have the software running. You can just connect it. So you don't need to install anything. Basically, just provision it and it's going to work. Yes, what's the question, Arvind?
Yeah. So Mahesh, just to sort of understand. So this memory store, is that like an attachment to Redis, or is it Redis itself?
It is Redis itself. It's a managed version of Redis. If you were to have Redis, you have to install it, right? On a server. Now here you don't need to do anything. You can also do a virtual machine, provision a virtual machine, install Redis. That is also possible. Instead of doing those stuffs, why don't you go with a managed version? So that's
Yeah,
what
the
we
reason why I got confused is the first bullet says data store service. So I thought maybe that is some kind of something that Redis
that the
itself
data
uses.
store is the normal data store is a normal term. It's a data store. It's not one word. It's not one word. Two different words. So a data store. It is an in-memory data to keep your data. So it's an in-memory data store service. Basically, I meant. What I meant was it's an in-memory service basically to keep your data. So you get one is Redis, the other one is a managed. Memcached. Two options.
Clear. And this would typically be in front of CBT?
It could be for any database as long as you don't. Now, I would say in front of CBT may not be a good choice because CBT always gives you low latency requirement. It's already low latency, right? So again, if you put something like this, is going to be something like this. The flow is going to be something like this at a very, very high level. User, there's going to be an app, www.myapp. So when he does log in into this, so this app may be running on a virtual machine or a Kubernetes engine. So what you will have is basically you will have a middle tier, then a DB, a database tier. This is what is going to be usually happening. Now, every time you're hitting the database and getting the data, instead of that, what you can do is have some kind of a caching mechanism. So your memory store. This one is going to hit your DB tier. So get it. And this is going to be served to your front end. This is what it's going to be. And this DB can be simple as MySQL, can be Spanner, Firestore, also your CBT. But I would not prefer to use CBT. The reason is it can give you the stuffs basically very fast. So already the latency requirement, 6 milliseconds, if it's not still enough, then loading the data into memory store could be a good choice. But assuming the amount of data which you're going to put in CBT, loading that into memory, I'm not sure whether it's going to make sense. Usually people use memory store in conjunction with Cloud SQL or Firestore. This is what I have seen people using this, or sometimes Spanner also. Spanner I have never seen, but possibilities are there. So these are the possible options. to keep your data in the memory so that you can retrieve it much faster in sub milliseconds, basically.
Yeah, thanks, Mahesh.
Yeah. Now
Mahesh,
it's
one quick
just
admin question. Sorry, one
yeah.
admin question. What's the correct etiquette to ask a question here? Like I simply say I have a question, and you allow
You
people
put
to
it
ask.
so yeah. Basically, if you can wait for a question to be answered, you put it in the chat. But if you have a question without understanding that question, you cannot move forward. You will get blanked out. You can speak out. You can speak out. You can say. Usually, when you unmute yourself, I can hear it. There's going to be a noise. It's going to be a sound which comes. I understand that somebody has a question. You can either
Okay.
put it in chat, or if you want to ask, it's your choice. But if it can be, you can wait. You can just wait till I finish the part of it. Or sometimes if I'm in the middle, I'll definitely say, just give me a minute. I'll finish it, and then you can ask.
Clear. Thank you.
Okay. Now let's create our memory store first, folks. And when we are finishing our memory store part, we will also understand whether it's a zonal resource, all those things, zonal, regional, all those things. Now, if I go to memory store, you have two options. Redis is one open source version of in-memory database, and Memcached is another open source version. So both of them they provided. I have not worked heavily on Memcached. Looking into the various documentation, I prefer Redis is little better compared to Memcached. So I'll use Redis. Maybe the API may not be enabled. Let's see whether the API is enabled or not. If it's not enabled, let's enable it. Creates and manages Redis instance on Google Cloud Platform. Now, as I mentioned, this is very much similar to your Cloud SQL instance, a managed version. Now, any guess, folks, when I enable the API and create a Redis instance, whether it's going to be zonal, dual zone, regional, dual region, or multi-regional or global resource, what it could be the possible one when we create this? I get one response from Kumar. So if you can put it as private, folks, so that everybody can think. So whenever you're answering, please put it as private so that others also think. So what could be the possible scope of this Redis or this memory store? Is it going to be zonal, regional, multi-regional, or global? Guess is okay. Guess is totally okay. But based on the concept, I told it is very much similar to your Cloud SQL instance. Very much similar to your Cloud SQL instance. If it's very much similar to your Cloud SQL instance, Aman is right. It is going to be zonal. It's nothing but a virtual machine, folks. It's nothing but a virtual machine. So it's nothing but a virtual machine. Where will you provision a virtual machine? The basic is always in a zone. So this is also going to be in a zone. In literally, right, if you see it, they provision a virtual machine behind the scene. They, in the sense, Google, they provision a virtual machine for you, and in that virtual machine they will install Redis instance. So that you don't need to juggle around installing the dependencies, all those things. Yes, the VM is always in a zonal instance, so it's going to be, yeah, this is also going to be zonal. So let's create it. So instance ID, I'll call it as memory store. And because there are two options which you get, right? Memory store Redis, memory store cache. The way Google usually uses this term is memory store for Redis, memory store for Memcache. That's how they use it. So similarly, like if you have SQL, MySQL, Postgres, and Microsoft SQL Server, the way they use this is Cloud SQL for MySQL, Cloud SQL for Postgres. That's how you should use. I would say that's the better way whenever you're talking to a customer. Just don't say we will provision a Cloud SQL for you. Be very specific. Cloud SQL for MySQL. By that way, right, the customer will never assume, okay, I'm not sure what this architect is going to design, whether he's going to use MySQL or Postgres. By using the words silently like this, right, it's going to convey a better message to your customer. So be very specific. Cloud SQL for MySQL is what we are going to use. And to have a better caching experience, we are going to use memory store or cloud memory store for Redis. So that way the customer is very, very clear what are the components you are going to use, basically. Okay, so use that terms. So memory store for Redis batch 6. So that's my instance ID. If you want a display name, the display name can be anything. Demo on Redis. That's only for us humans to know that, basically. Now, you get two tiers, folks. Two kinds of tiers. One is a basic tier, which is used for development purpose because it does not have a high availability. If you can connect your Cloud SQL, you will be able to see it very much the same. So basic is without HA or failover. Standard is going to have a failover replica in a separate zone, but in the same region. So if I make it as basic, you see the price. If I make it as standard, you see the price. It slightly increases because there's going to be a replication there. Now, it should be available in almost, it's currently available in limit. Oh, it's available almost in all regions, all the regions. Basically, it's on a virtual machine, right? So if I create something in Singapore, any zone, if you give it as any, Google is going to decide. If you say particularly I want it in A zone, you can mention it. So this is the cost. If I go with standard, when should you go with standard? Basically, when you're creating a memory store for Redis in a production environment, so that you have a high availability. One zone goes, still the other zone will continue, take over and start the work. So in that case, you can use standard tier. But if it's for development purpose, you can use a basic one. And because here everything is going to be memory, you'll never have any option of mentioning the vCPU details. So it's going to only ask what is the storage you want to go for. So max I can go with 300 GB of RAM. It's RAM, folks, not SSD disk or storage HDD disk. It's going to be 300 GB of RAM. If I go with standard also, it's going to be the same. Maximum is 300 GB of RAM. So let's make this in our cheat sheet so that we are not forget this part. So memory store is a zonal resource. It's a zonal resource, and Cloud SQL, I can make it as failover replica is I'll just mention storage is RAM. Max storage is maximum storage is 300 GB. That's the max. That's the max. So let me make it as 1 GB of RAM. That's enough for me. 1 GB of RAM is enough. I'm going to use the basic tier. That's good enough. And this is the important stuff. What version of Redis you want to do. Now, if there's a question, not the exam question, but from the customer saying that we have a Redis instance, we want to run it in cloud. The first question which you should ask is, what is the version of your Redis? What is the version of your Redis? Ask this question. If they say specifically 6.0, the latest version is 6.0. If you just search it in the net, you'll get it. If they say 6.0, then you cannot use memory store for Redis because it does not support. It only supports 3.2, 3 or 4.0 and 5.0. If you have something older or something very specific, you have to use some other option. I'll show you what is that option in a minute, but the supported versions are only these things. So in your implementation documentation, you can add this if you want, so that you can ask the question to the customer. The supported versions are only supported version of Redis are 3.2, 4.0, and just for your information, the latest is 6.0 in cloud memory store. So if it is anything like apart from this, it is not going to support unless they are using some specific feature request. Say for example, in maybe 3. I'm just assuming there was a version called as 3.5. There was some specific feature in that, and that feature was available only in 3.5, not even in 4.0. Then you are forced to use that specific stuff. Means you have to either install it on a virtual machine, or look for something in a marketplace. That is another option. There is also one more option called as partner solutions, which is recently, like I guess 1 year back, they made it available. You got good amount of partner solutions, so you can directly purchase Redis enterprise version kind of a stuff. So you can purchase that also. I'll show you that later. So let's go with the latest, or the so-called latest version, Redis 5.0. Provision that's good enough. What else? We don't have much exposure in networking, so I'm just going to leave the networking stuff as default without doing any much changes. So what I gave, basically create a basic version, then selected a zone, the capacity is in RAM, the RAM capacity, then the specific version of Redis. That's it. Click on create, and this is going to take around 7 minutes. Very similar to your Cloud SQL instance, where it's going to create the virtual machine and the Redis is going to be installed. Some configuration is going to happen behind the scene. It's going to take some good amount of time. So by default, Redis listens on 6379 port. You don't need to remember this. Nobody's going to ask you. But this is a port it's going to listen on. So when you're connecting it, it can help you out to connect basically. And one thing which is very, very important as a cloud architect, which you should be designing that stuff is, if the requirement says a Redis instance is required and developers needs to connect it, all those things, basically what you should do is you should have a Bastion host, folks, or a jump server, because the Redis instance will always give a internal IP address. It will never have an external IP address like your virtual machine. So if you are in your corporate office and it is not connected to any VPN or anything with GCP, then you cannot even connect to this basically. So you need to have a jump host or a Bastion host to connect it. So this is the design factor which you have to put. Uh, I had faced this challenge in one of the implementations, so I had to give them access, and they were using their own laptops. So from their laptop, they wanted to connect to Redis, so which was provisioned in GCP. So I had to create a Bastion host and had to do some port forwarding and all. Then they were able to connect it basically. So this is an important thing. So this is a design factor. Now you don't need to get into the details of how do I query memory store, all those things. That's not our this thing. But you need to give access so that or when you're creating the design document, you should mention it. A Bastion host or a jump host to connect to Redis is required. Basically, that is very, very important, at least in the dev environment. Production environment, you may not need it. Maybe from a Kubernetes cluster or from your virtual machine or even from your app engine, cloud run, cloud functions, they can connect it because everything is going to be in cloud. But if you want to connect it from outside world, you need to have a host, a Bastion host. Basically, you're going to create a virtual machine and then connect it. Okay, so as a general practice, I would recommend TLS. It would, but I would like to have the performance impact like that. So turn on the TLS part. Okay, you can. So when you want, you can turn it on. So I kept it as simple there. So you can definitely turn on the TLS there. So that's going to be better always. So it's basically like having the next version of SSL. So you should be able to do it. Yeah, security from day zero. That's always the best thing. So totally agree. So it's going to take some time, folks. By the time this comes, the IP is going to be internal IP. How I can say very confidently it's going to be internal IP? Once it comes, you will be able to see it. It's going to be internal IP. It's going to be in a specific class. There are some 3 classes which we will be learning in our networking, called as class A, class B, class C. Some internal IP ranges. By looking at that, we can easily make it out. For now, just have an assumption or make a note somewhere that whenever you create Cloud SQL instance, it's going to be using, whenever you're using memory store, it's going to be using internal IP address. It's going to be using internal IP address. So let me see whether it is. Your memory store will not come behind your load balancer. It's going to be between your application, your VM connecting to your memory store. Your VM is going to be, so the path is going to be something like this. So if you were to see how I can put memory store, it's going to be basically user DNS, then your load balancer, then your managed instance group or GKE. That is going to hit your memory store. The memory store is never exposed to your outside world. This memory
Yeah,
store
what I
will
meant was, would there be another load balancer between GKE and memory store?
if you have because this is zonal resource, right? Now if you have your MIG across multiple regions, for every region you want to have some caching done, then you will have three, say for example, one in Singapore, one in London, one in Las Vegas. Then you may have three memory stores. Then you need to have an internal load balancer, which we are not even
Right.
come to there. So you may need to have an internal load balancer but not an external load balancer.
Right, got it. Yeah. So when you were creating the memory store, I saw there was an option for high availability. So
Yeah.
looks like it's going to automatically create a replica instance. So I was
Yes.
wondering,
In
and that
another
replica
zone,
instance in another
it's
zone.
going to be in
Yeah.
another zone in the same region. It's not going to go out of the region. It's going to be in the same region. So it's
Okay.
basically maximum a dual zone.
Yeah. So
So one,
that is
yeah,
better than nothing at least. At least it's not multi-regional, but at least it's not one single zone at least.
yeah. So all right, our memory store is created. You see this IP. For now, don't think much about it. So when we learn our networking class, you'll come to know this is an internal IP. So this is called as class A. I'll show more details about that in today's class itself. So this is basically a class A IP range, internal IP, RFC 1918 standard. More about that in our networking class. So this is an internal IP. Now I cannot even ping this from my laptop. So what I usually do is I create a jump host or a bastion host. Basically, create your virtual machine. So create your virtual machine. Okay, I'll create it here. So if I go to my virtual machine, I create a virtual machine and I can create it anywhere, folks. I can create it anywhere as long as it is in the same network. We have only one network, more on our networking in today's class only. So I'll create a virtual machine. So, but the best practice is always keep a VM very close to your memory store. Where is your memory store? If you can create it there, it's going to be good. You can also create it. I'll show you both the options. I'll create a memory instance in Singapore, something like Bastion SG Singapore. Then F1 N1 standard should be good enough. That should be good enough. All the default basically only the region is selected, zone, and everything is default. Let me create this one. I'll create one more in US Central. Bastion SG, sorry, US. I'll select it as US Central. Create it. So I have a Bastion host in Singapore. Let me connect it. And this has an external IP address. So I'm in my SG server. So let me just, Singapore server. Now what I will do is, if you want to connect to MySQL, you will have MySQL client. If you want to connect to CBT, you will have a CBT client. Similarly, for Redis also, you need to have some client installed on your Linux machine or Windows machine. You should have a, sorry, you should have a client basically. So the client is going to be called as, let me increase the font here. Okay. So you have to install this thing called as, first let me update the packages. So you have to install something called as Redis tools. You just search in the net, you'll get it. APT, and this is also mentioned in the cheat sheet. You can look into it. Redis. So before that, let me just type Redis. If I do, it shows command not found, meaning basically in a Linux, at least in Debian operating system, in GCP, you'll not have a Redis client installed by default. That is very clear. Now I have to install this. Sorry, Redis tools. Install it. Done. Now if I do Redis, it is there. You see it is there. It is there. Let me exit it for a minute. And if you want to see where it is installed, it is in /user bin. Okay. Now, if I just do basically Redis, it thinks there is a Redis instance in this server only, in this Bastion SG only, and that's the reason you see connection refuse, because it uses localhost. Now, what you can do is when you connect it, mention what's your host name. This is where the host which is mentioned there, the memory stores host 10.65.192.3, and the port, this is where the port comes into picture, -P6379. Now when I do this, I should be connected. It should not say connection refuse, it should connect. I'm connected. The only thing which I know about Redis is there are few operators available. You can use one operator called as increment operator. Maybe think like you wanted to store all the people the visitors who's coming. You want to have an increment tool. So you can have something called as increment tool, counter underscore batch 6. When I do increment, it's going to increment it by 1. Now, if I run it one more time, it's going to increment by 2. Basically, this is how I can do. So this is one operator. If I do this kind of a small sanity check, I can confirm and say that this instance is running fine. So basically, these are the something which is going to help you to say, okay, everything is working fine. Over to the developers, they can start working on it. Now you have the option of taking backup. If I just go here, you can take backups. All those options are going to be there. So you can export. Where usually it's going to be exported, folks? Any thoughts? What could be the possible sync? Without I clicking on it, you should be able to say one thing. The most possible option. Yes, Arvind. Anybody else? The most possible option to export it. Yes, Mangesh. Yes, Anil Kumar. So it's always going to be our favorite product, Google Cloud Storage. Yes, Ankit and Vivek. That was correct. So if I click on export, it's always going to be by default your Google Cloud Storage. Now you really now understand why Google Cloud Storage. Yes, when in doubt, you can just usually use Google Cloud Storage. So that's going to be your staging environment for most of your resources. So you export it. Then if you want to import it to some other instance, you can do it. So when you export it, it's usually going to be in the form. So do I have any bucket? Let me just export it. So when I export it, right, usually it's going to be in a format called as .rbd, Redis DB. That is how it's going to be. So let me just make a good name. Batch 6 RDB, Redis database. Export it. So it's going to export the data. Once it is exported, you create another instance. You want to import it, you can import. Basically, that is something which you can do. Out of curiosity, let me go and see the data, okay, so that I can show you what is actually in there in that data. You'll get some idea. It's going to be in a binary format, but you will see some info. We created a variable called as counter batch 6, right? If you go and you will see the value as 3 or 4, what was the last value which we gave? That information is going to be there. Just out of curiosity, just to show you how you can see those backup information. So if I just launch my Cloud Shell, so if I put gsutil ls, so this was the data which we had, right? So if I use gsutil cat, what was that? Batch 6.rdb. Maybe I should have downloaded it. Let me download it. I have this file. Let me just open this. Out of curiosity, folks, that's it. It's going to be usually in a binary format. If I can see some sense, can I make some sense out of it, is what I'm trying to show you. Okay, this is how it shows. You at least see there was a variable which we used. You see this? Everything is a binary format. It's not good to open a binary content, but people who are very curious to know how it works. Yeah. So if you see this, you will be seeing batch 6. There was a variable which you created. Okay, good. That's it. So now you should be able to import it into another instance. Maybe this could be helpful. Maybe from one project to another project, from dev to production, you want to move. This could be one option which you can say, basically. Now let me show the last part of the demo, where from a totally a different region, but all are in the same network. So if I see my MySQL my memory store, it was mentioned that it is in default network. My VMs, we have only one network. My VMs are also in the same network. So I can even connect from a different location as long as the VM is in the same network. So I'll just do that one more time. Waiting for the connection to establish. Not even connecting. Let me just click it one more time. What's happening? I'm not sure what's happening here. 1 minute. Let me just connect it from the other side. If I can go, I'm not sure why it's not connecting. Let me connect it from here. I need the memory store IP address. And once we finish the demo, we'll make a note in our implementation cheat sheet that you should have a Bastion host. That's a mandatory one. At least for development environment, you have to have that. Otherwise, it's not going to work. You cannot even connect it. Why cannot we connect using IAP? Possible, you can, but you need a host with at least a VM is required. Basically, you cannot directly connect it. So basically, you need a VM. Whether it is having an external IP address or internal IP address, that is secondary, but you need to have a VM to connect it. So because this is all in memory, right? So you have to have a client basically. So if you want to connect it using internal, but you will not have access. Only this port is opened. Only this port is opened. This port is open, nothing else is opened. Okay, only 22 port is not opened. It's only one port specifically which is open. So
even if you put a firewall rule opening port 22,
no,
you can't.
that's managed. That's managed. That's a managed
Hmm.
instance, so we cannot put anything.
Okay, I see.
So
Interesting.
yeah, I'll install. I'm in US server. Install Redis. Redis client minus h 10.65.192.3 minus p 6379. Now I'm there, I'm connected. Now if I just do increment, what was that name? Counter underscore 6. You see the value is retained. There it was 4. Now when I run it from US, it shows 5. So you see the connectivity is there. I can connect it and the value is going to be retained, but everything is going to be in the memory. Everything is going to be in the memory. So if you delete the instance, it goes off. So that's where that exporting and importing is going to help you out basically. So that's something on Redis, folks. If you're interested, you can do a demo on Memcache. I've never tried Memcache. Basically, that's also an open source in-memory database. I was looking into some documentation. They were comparing Redis versus Memcache. Redis looks much better compared to Memcache. So that's the reason I thought let me show you the one which is very popular. At least you get an idea how in-memory database works. That was a whole intent. Any questions on this, folks, before I delete it? Because it's going to take 7 minutes to provision.
Yeah, one question. You said that this, or I forgot actually. This is not creating a VM in the background, right? Or even if it is, it's not accessible. Is that correct?
Yes. It's going to be something like a VM behind the scene, but you will not be able to access it. So maybe if you just go to your virtual machine screen, you'll come to know there is nothing on that, but by that name.
Got
you will
it.
not have an instance. But there are few products which we will see in the future. For example, data proc, cloud build. I guess cloud build, not cloud build, sorry, data flow, data proc. When you create a managed version, you will see a VM here behind the scene. So you will see it. But this one is something which you will not be able to see. It's going to be in a private. It's going to be private. We will not be able to see it.
Private VPC flow.
I don't have any. Something of that sort. Not even private VPC, maybe something. It's something which is not visible to us in very simple terms. Instead of putting a wrong term, it's going to be in a region or in.
It's
Which
going
is
to be
not visible to
Google
us.
managed. Google managed and controlled whatever it is, VPC or whatever.
Yeah,
We can't see.
correct.
Yeah.
Yes. So you see a memory store is there, but you cannot see any VMs behind the scene, basically.
Yeah, that makes sense. Thank you.
Yeah. Now, you also have the same concept, show info panel, but here the access is nothing to do with the access. It's only labels is what you can give. So only
I think for
labels is
access, you have a auth column there, right? Maybe that's what controls it. When you created
okay.
the cluster, you had an auth option. Here you have disabled it.
Yeah. That's going to be something based on you are going to do the authorization. Prevent accidental access by automatically generated for you. It's not intended to protect malicious attack. Okay, good. So let me just delete this instance.
So if we have to play with like an actual, like maybe like end-to-end use case, I assume we can look at like quick labs or something, right? Is that usually what's recommended? Like for a lab?
If you have a quick lab, if you have a quick, if you have a free tier account already, that's going to be better, because quick labs, usually what happens is, if the quick lab says you have to create only VM, in that quick lab, if you go and create a big table instance, they will ban your email ID. Then you have to raise a request and do it. So there's some terms and conditions. What they say in the lab, only that you should do. If you do something extra, they will ban the IP. Sorry, ban the
Yeah,
email
understood.
address. So,
But
so the better one is,
unless I'm like a Redis expert, I will not like know what is a like sample use case.
I would say, I guess even in quick labs, you may not have end-to-end demo for Redis. Even there, they would have shown something very similar, is my understanding. So if you want to have an end-to-end, basically you have to uh, look for some use case and try to do it. So some code, something you have to explore, then only you will get it. But the best place I would say is to have a free trial account. That way you will be able to try each and everything without much restriction for 90 days. Yes,
Got
quick
it.
lab,
Yeah.
I also got blocked once. Like I thought I was smart. I created, this is what the exact thing which I did. I thought, okay, anyway, a big table, I cannot create it in my free trial account. It's expensive. Let me use a quick lab. So I launched a lab for VM creation and tried to create a quick big table instance. Next few minutes, it was blocked. I was not knowing why it is happening. Later, then I realized that it is not as per the terms and services. What they say in the lab, you should only do it. And later, I realized that that also incurs the cost, right? So you are in quick labs, there's going to be something called as credit, one credit for one lab. So if you are buying a credit for one credit, if VM creation is one credit and a big table to create is going to be 5 credits, you're paying less and doing something more. So as a penalty, they just block your email ID. Then you have to again go raise a request. Sometimes they remove it, sometimes they don't remove it. So it's going to be a little tricky there. So be very cautious.
Thanks.
Yeah. So the last storage component which we are going to discuss, afterwards we can definitely jump into maybe we can take a break also. So last component in our storage, file store. Very simple. This is a NAS storage, nothing else. Network attached storage which leverages your network file system protocol. A NAS storage, whenever you hear of a NAS requirement, you can go for file store, NetApp, all those kind of stuff. Similarly, Google also provides file store. Now, to be very frank, right, I'm not a great fan of this. Yes, I'll come to why Google Cloud Storage not an option. I'll tell you that. To be very frank, I'm not a great fan of file store. File store, fire store, you will have lots of stores, folks. Data store, file store, fire store. Please be very cautious when you're spelling it out. So this is file store. This is the network attached storage, basically, which uses your network file system protocol. Uh, as I mentioned, I'm not a great fan of this. The reason of this is basically the reason why Google created this. If you ask me, assume you are responding to a tender document or an RFP or RFI. There could be definitely tenders from other public cloud providers also, AWS, Azure, all those things. So if the tender specification says, I want a managed NAS storage, if they say something like that, right, then you have to say compliant or non-compliant. Now you cannot say an alternative. I'll provide you an alternative like Google Cloud Storage. That's going to be partially compliant with respect to the compliance there. So to make at least the tender document compliant, sometimes cloud provider creates such products. File store, uh, slowly evolving, but from the tender perspective or from the RFP perspective, you can make it as fully compliant. But when you start using it right, you'll be really shocked with the price which it provides. And one difference, why cannot I use Google Cloud Storage instead of file store? First of all, Google Cloud Storage, GCS, is a binary large object storage. Your persistent disk is a block storage. Your file store is again going to be a block storage. Meaning if I were to do editing, file editing, changing the files, I can use persistent disk or file store easily. But if I were to edit a file, can you edit a file in Google Cloud Storage? No, you have to upload a new version of it. That's it. So it's not a block, it's not stored in blocks basically. So that's the reason in some requirements where you want to have a shared drive, you want a shared drive. Uh, yes, Google Cloud Storage is immutable. So if you were to edit something, you have to upload a new version of it. Basically, that's it. You cannot edit it. But if it's a persistent disk or a file store, basically you can go edit it, and it can be shared in read and write mode to n number of VMs. Now, if you have a persistent disk, right, one persistent disk can be attached to n number of VMs in read-only mode. Read-only mode. You cannot have it in a you cannot have it in read-write mode. Only one more VM can be in write mode if it's a persistent disk. So if you have a requirement where you want to have a shared drive which is going to be read and write, then your file store is a good choice. This is to people who have something like that. Yeah, if you want, this is going to be your file store, folks, whenever you have this requirement. And please remember, this file store is going to be super expensive. I'll show you this thing. I'll not do the complete demo. I'll just show you the pricing part. It's going to be super expensive product basically. And if you have a file store, you usually do a mounting like this, the IP of your file store, the thing, and you should be able to connect it. You can connect from a Windows machine, from a Linux machine, from any kind of machine. Multiple rewrites are possible, Vivek. So this is where you will do it. So here, n number of VMs in read-write mode. Read-write mode is possible. Here it is only read-write mode is possible. So that in some cases, I always was using persistent disk many times. But if I use persistent disk, it's going to be read-only mode. But if you want multiple VMs to read it and modify it, all those things, definitely file store is a good choice. But if it is only for sharing some, if you see in your organizations also, right, the IT people, they will have a shared drive where all the softwares are kept. If it's only softwares which you're going to keep, I would say even Google Cloud Storage is a good choice. But if it's a shared document or something of that sort, then file store can be a good choice. File store could be a good choice. Let me just show you a small demonstration of it. I'll just show this part and then we'll take a 10 minutes break. Sorry, not this place. So if I just go to my last storage option, which I have, under databases, we finished everything. No, I did not even create it. File store. I deleted the file store, memory store. Only the screen was not refreshed. That was the reason it was showing up. File store is for creating and managing your file servers, similar to your NetApp. So enable the API. You can turn off, turn on via any kind of medium. You can use either the console, G Cloud command, deployment manager, which we have not seen, Terraform, which we have not seen. It is possible. You can control it. So let me create an instance, a fully managed network attached storage system that you can use with Google Compute Engine and Kubernetes Engine. Very specific, folks. Don't expect too much out of this. It's only from Kubernetes Engine or from Compute Engine. Simple. That's it. Not from your App Engine, Cloud Run, Cloud Functions. It is not possible. So if I give a name file store batch 6, now you get two options. One is in beta, so we will not even look into it. The one which is in generally available is basic, general purpose NFS storage system optimized for storage. So you can go up to 64 terabytes, folks. 64 terabytes. That's it. So this is one important thing is the moment you provision file store, whether you use it or not, the billing is going to be there. It's like your persistent disk. It's not a serverless one. So it's not a serverless one. The moment you click on, say, for example, you say, I want minimum 1 terabyte, your bill starts right now. So the maximum which I can go is 64 terabytes. That's it. A NAS storage with only 64 terabytes, I would say, is of no use, is my understanding. So whenever there is a huge volume of data to be stored, basically some kind of software, some images, kind of a stuff, I would prefer to use Google Cloud Storage. Even towards our last day in our training, we'll be looking into one case study where they will mention specifically they want a NAS storage. But in that NAS storage, if the volume is more than 64 terabytes, I cannot use it. At least in GCP, I cannot use it. Or I have to have two NAS file store, which is going to be super expensive. So if I make it as just 64 itself, look at the cost. Look at the cost, folks. 13K. I guess it would be some of one person's complete salary or more than a complete person's salary. It's going to be really a very huge one. And the most important thing is I have not even made it as this is HDD. If I make it SSD, the heart attack may be much severe there. If I make it as 63.9, it is 19,000 US dollars. So it's going to be very, very high there. And the worst part is it's a zonal resource, folks. It's just a zonal resource. Giving something at this high price, I don't even think is going to be basically. So that's the reason I totally avoid this product in any of my architecture. Just keep this at the back of your mind. If there's a compliance requirement, just have it. That's it. The best option, if I were to keep this kind of data, if you just compare it, 64 terabytes, why don't we do that quickly a comparison? Assume it is all softwares, nothing else. So if I just go to my pricing calculator, use Google Cloud, and it's not a good to compare it, but Google Cloud Storage can do this part very well. So if I go to storage, I'll keep it as hot only. So this is in which place? US Central. This is in oh, sorry. Sure, sure. So if I make it as 64 TB, right? Yeah, 64 TB. 64 TB. That's it. Hot data. If I just had it, look at this, folks. $1,300. But look at your this thing. So vast, so vast. And only if you keep totally 64 terabytes only, you'll be charged this much. If you keep less than that, it's going to be little little less. So, but here, whether you store data or not, the moment you mention 64 terabytes SSD in US Central, your bill will start from that time onwards. At the end of the month, you are going to get close to 20K as a bill. So possibly, wherever it is required, don't use this because this is a zonal resource. It's a zonal resource. You have to have multiple stuffs, multiple such instances. If you were to have at least even multi zone, it's going to be an expensive product, but just for the compliance purpose, you can keep it handy. So if I just make a note of this one, for example, backup, this itself is going to be if you want to take a backup, you have to create one more zone. That's it. So you have to have one more zone basically. So let me just add this. It is zonal only, very, very expensive. Keep at the back of the mind. Possible alternative is GCS, folks. This is what you can do. So I'm not going to do a demo on this. So once you create it, what basically happens is it's going to give you an IP. It's going to give you an IP address. That IP address you use and mount it basically, and you should be able to access from Windows and from Linux machines usually. That is the whole purpose of this file store. Just as a information, keep it. I never felt a need of a file store in any of the projects which I did. May not be great projects which I did, but at least in the projects which I did, I never felt a need of this. So the only thing is in AWS also you have something called as elastic file store. Just to make it, yes, we also have a product. Google would have created this one. Maybe in the future the price may drop. And there is also a beta version which is coming up. If I just go in the beta version, you can go up to 320 terabytes, which is going to be, I would say, the maybe 1 year's salary of some people, 100K in US. So it's going to be really very, very expensive, but it is still in beta. So, but it's never in petabytes. But when I keep it in Google Cloud Storage, I can easily keep it in petabytes. That's something possible. Okay, just keep that in the back of your mind. Can we place our own SAN storage? If you keep that, then you have to have a connectivity between your GCP products and your on-prem. So then you have to have a connectivity like your VPN or something. So that is going to be again consume cost. So this
Mahesh,
side,
just a joke
yeah.
actually. We we can place our whole server in this cost actually. What
Okay, that's a good.
$100,000?
Okay. Okay, okay, good. So it's very expensive. Some products are very, very expensive. So be cautious about it because as a cloud architect, wherever possible, not wherever, every time we should propose a cost-effective solution. So this is going to be super high actually. So that's on file store, folks. What we'll do is we'll take a 10 minutes break. Once we come back from the break, we will look into a decision tree, like how we did with our storage. We do the same thing, a decision tree, when to use what. so that we have seen so many products in storage, right? We'll get an idea when to use what. Something very similar what we did in our compute module. Okay, take a 10 minutes break, come back. After this, there's a couple of questions which I have. Once we finish it, we'll just kickstart our networking module. Just this thing. Okay, so I'll put it to have a break. Let me stop the recording first of all.
This conference will now be recorded.
All right. Before the break, what we saw was the last storage option which we had in the category. Now it's good, and we'll always follow this as a practice. Every time when we finish a module, we'll have some kind of a decision tree which is going to help us when to use what. So that's very, very important. So many products will definitely create confusions only. So to avoid that, and I would say credit goes to Google. So they create good decision trees always, which helps us. And this is something which I've taken directly from the website which I mentioned, cloud.google.com/storage options. You can also go, or you can look into the PDF document. You should be able to see it. The first option, whenever you want to decide something on storage, the question which you need to ask is the type of data. Is your data structured? You remember we had discussed, is the data structured, semi-structured, or unstructured? So if the question is your data structured? If that's the question, and you ask this question to the customers, folks, basically, you ask this question to the customer. If the customer says, no, I'm going to store some videos or some images to be rendered, meaning it's an unstructured information. So if the answer is no, you ask a question whether it is for some mobile SDK. And we have not even talked about mobile SDK. That's not our interest also. But if the question is not towards mobile SDK, then the product which you're going to use is our favorite product, Google Cloud Storage. It can take any kind of data, basically. Now, if you say, no, my data is going to be structured, then you ask a follow-up question. Is your workload analytical, or is it going to be OLTP or OLAP? If you say it's going to be analytical in nature, meaning you're going to do some analytics, use some BI tool to visualize all those things, the answer is going to be yes, means you go to this branch. If you say no, it's going to be the opposite of analytics. Is what? It's used for transactions. So if you say it's going to be for transactional purpose, you come to this no. You ask a follow-up question. Is your database or your data relational in nature, where it's going to be rows and columns, there's going to be a relationship kind of a stuff? Then you say yes, you come here, you ask a follow-up question. Your data is for transaction purpose, it's relational in nature, it is structured data. Do you want horizontal scalability? If you say yes, the product is going to be Spanner. If you say no, I don't need it, I don't need a horizontal scalability, is only in a specific zone I want because it's a small e-commerce website, then it's going to be Cloud SQL instance. Simple. So it's going to be a Cloud SQL instance. So if the question is towards structured for doing transactions, it's going to be relational data, then, and no horizontal scalability, SQL is a good choice. Otherwise, Spanner is going to be a choice. If you go up the ladder and stop here, if you say my data is not relational, it's going to be little semi-structured in nature, and it is not for mobile SDKs, then the product you are going to use is basically Firestore or Data Store. So we covered almost all the left-hand part of it. Now the only left part is your workload analytical? We said no, ours is transactional in nature. That's what we mentioned. If you say it is analytical, then you have two questions. Do you expect some low latency in your reports? Then the answer is big table. If you say no, I'm not, or I'm okay to have a response even in few minutes, but not in hours, but in few minutes, then you can use a product which we have not even discussed yet, called as BigQuery. So where the latency is not a major concern, but cost is a major concern, means BigQuery is a good choice. So products which we have not seen in the flow chart here is what is that? Memory store and file store. Remaining everything we have covered it because it's an older decision tree, so they have not updated it. This is a decision tree which could be really helpful, and it's worth taking a screenshot of this and keeping it in our both the cheat sheets, implementation cheat sheet and in our exam cheat sheet. So I'm just going to put it in the cheat sheet quickly. And I had one more point to add in the implementation. What was that? This is the one. So all good. So uh, really a useful cheat sheet. Now we come to the end. We had already done some part of the quiz during our Google Cloud Storage. So I'm going to skip those questions which we have already discussed. So things which we have not discussed, I'm going to jump in there. The last question which we discussed was this one, if I'm not wrong, where we had decided transfer service is going to be a good choice. This was the last question which we discussed. We stopped at this stage. Now, please everybody change your mode to private mode where only you send a message to me because we don't want to bias others in the response. So let me first change that mode so that we don't have any issues there. The question is like this. Your company's architecture is shown in the diagram. You want to keep the data across in sync across region 1 and region 2. Which product should you use? This is the question, folks. There is a load balancer. There is 2 Kubernetes cluster in region 1, region 2. We know Kubernetes can be created as a regional resource. And there is one component which we don't know. What is that component? Which is going to help us sync the data between 2 different regions. Let me know the answer. I'm going to give you 2 minutes and please put it in your chat, private chat. Vivek Aravind has got it correctly. One wrong answer. Two wrong answers. Deepak Bandari got it. Kumar got it. Another wrong answer. One last minute, folks. No, 3 wrong answers. Mangesh got it correctly. I'll give you an explanation. I'll give you an explanation. Don't worry, folks. So, all right, let me stop the timer. Now, let's look into the option. A tricky question, even though it is a point answer, product basics, that's it. So basically there's a load balancer. It balances the load like what we had seen. Instead of MIG, they are using Kubernetes cluster, no problem. Now the data is going to be synced. That's what they're saying. They want to keep the data in sync across region 1 and region 2. What is this product? First of all, the hint to this question is if a product or a service which you're going to use which can sync data from 2 regions, basically it should have at least bare minimum capability of being a regional resource or a multi-regional resource. Then only it can be able to handle that, right? That is what I would assume. as a basic necessary criteria to use a product. So it should have at least regional capability, or multi-regional is going to be good because it needs to sync from multiple regions. A multi-regional product or a global product is going to be too good for me. This product should be either global, multi-regional, at least dual regional, or the worst regional. It cannot be zonal. That is my understanding, folks. With that base, let me go to the options. First of all, I'll see Cloud SQL. Now, Cloud SQL is going to be zonal in nature. And we don't know, they are mentioning keep the data in sync. What type of data? Have they mentioned it? So data can be structured, semi-structured, or unstructured. We don't know any details of it. And we cannot even assume it. What you can assume is any kind of data. It should be able to fit. Can I put a video into Google Cloud SQL? If there's a video generated and it is going to be stored, can I store it in SQL? No. Only I can keep only structured information. And Cloud SQL instance is a zonal resource. So A gets ruled out because of that. Because they have not mentioned what is this data. Is this data structured, unstructured, or semi-structured? So I cannot use only a service which can only handle structured data. So ruled out. Big table. I will rule this out again because it's a zonal resource and you can only keep structured or semi-structured information. Moving to Google Cloud Storage, what it can store. Can it keep a CSV file? Yes, but it cannot query it. That's secondary. Can I keep a video file? Yes. Can I keep a JSON file? Yes. Can I keep a PDF file? Yes. You tell me the type of data, I can keep it in Google Cloud Storage. No problem. And is it zonal? No. Is it multi-regional? Yes. Is it regional? Yes. Is it dual region? Yes. So it can fulfill all the requirements. Only thing is that it's not global and you cannot query it. So they have never asked, I want to query the data. So C looks like a better fit for me compared to Big Table and Cloud SQL. Moving on to the last option, data store. First of all, is data store zonal, regional, or multi-regional resource, folks? What is that? It's multi-region or regional. Good, a good fit for syncing. But what kind of data you can store in data store? Can you store a video? Can you store an image? No, I can only store structural information or textual information. So even though it is regional, multi-regional, I cannot store a video. I don't know what kind of data is coming here. Either you ask question the color, or you have to assume any kind of data. It could be any kind of data. Who knows? There is a code which is generating a video. Who knows? It could be anything, right? So the one which can fulfill our option is going to be Google Cloud Storage. Hope the explanation is clear, folks. Some of you got confused with this. Some of you got confused with this because usually we think the middle layer of the data is going to be always a database, right? That's what usually we think. But in this case, it's syncing and they have not mentioned what is the type of data. Hope the explanation is clear, folks. And this is my own understanding of the explanation. Okay. So the answer is Google Cloud Storage. Moving on to the next question. This is more related to our encryption. Google manage the encryption keys which we discussed. So you created a job which runs daily to import highly sensitive data from an on-premise location to Google Cloud Storage, on-prem to GCP. You selected, you also set up a streaming data insert into Google Cloud Storage via Kafka node that is running on a compute engine instance. So just to visualize it, don't directly jump into the question or the answer. So you have on-prem, then you have Google Cloud Storage. Also, you have basically a GCE instance which is running Kafka, a streaming, a messaging service, Kafka, Apache Kafka. Those are the stuffs which is running. You want to encrypt the data at rest and supply your own encryption key. You is the customer in this case. Your key should never be stored or should not be stored in Google Cloud Storage. So supply your own key. Key should not be stored in Google Cloud Storage. What should you do? Without I showing you the option, what is the option which you can think, folks? You should only supply the key, and you should not keep it in Google Cloud Storage. What should be the product or the specific key which you should use? By just looking at the question itself, one thing should have already come to your mind. Yes, Vivek. Anybody else wants to comment? No. If I use KMS, KMS runs in GCP, so I keep it in GCP. I don't want to keep the key. That's what they are saying. It should be stored, not stored in GCP. So what is that option which you can use? Yes, Deepak. You did not give the name, but your message is indicating what you wanted to do. That's good. But there's a name to that. Think about that, Deepak. Your answer is correct, but need a proper name for that. Anybody else, folks? How do you keep your own key? Yes, Anil B. That's correct. I'm just going to give 30 seconds for you to think. I want to keep my own key. The question is, you want to supply your own encryption key and you don't want to keep it in Google Cloud. You don't want to keep it in Google Cloud. Customer, yes. Now it is correct, Anil Kumar. Now the option is you have Google Managed Encryption Key, Customer Managed Encryption Key, Customer Supplied Encryption Key. This is what is required, needed. This is what is needed. By just reading at the question, I should be able to see it is somewhat related to Customer Supplied Encryption Key. Customer supplies it, they manage it, they keep it in their on-prem. Nothing is going to be in GCP. Whenever they are reading it, maybe in the memory for a short time, it's going to be meant. On-prem means it cannot be decrypted. No, it can be used, but you don't store it in GCP. If you were to store it in GCP, you have to use key management service. You have to use key management service, which is a GCP product. So must be a customer supplied encryption key. Now, without looking into the answer, by just reading the question, this should have struck you, folks. This should have struck you. Don't always look for an answer and then come to the conclusion. Sometimes in the exam, right, by just looking at the reading the question itself without looking into your option, you should be able to do it. Do they ask questions about the products is regional or zonal? Yes, Anil Kumar. Sometimes they will not directly ask you the question like that, but scalability wise, something like that they may ask. So at that time, our cheat sheet can be helpful. In KMS, is some part of the key stored. So only during the only when you're reading, writing, it's going to be in the memory. Your customer supplied key. Afterwards, it's not going to be stored in GCP. Only during that process of reading and writing, it's going to be used. Afterwards, it's going to be not stored anywhere in GCP. Okay. So now look at the options and let me know the answer, folks. I'm going to give you 2 minutes. Please put it in your private chat to me. You got the gist? You should be in a position to answer it. Bang on, Vivek, Anil Kumar, sorry, Anil B. Vivek Kumar and Anil B got it so far correctly. Deepak got it correctly. Anil Kumar got it correctly. Mangesh got it correctly. 50 seconds over, folks. One wrong answer. Aravind got it correctly. 2 minutes. The reason why, folks, I put is basically in the exam also, if you practice this 2 minutes, 2 into 50 questions. In 100 minutes, you'll be doing it. So you'll have 20 minutes to get it, to do some verification. Sorry, yeah, 1 minute, yeah, 20 minutes extra you'll have to verify all those things. Yes, Arvind, that is correct. Last 20 seconds. Aman got it correctly. Kumar got it correctly. All right, folks, time up. Now, you may blame me. Oh, Mahesh, customer supplied encryption key, nowhere it is mentioned. You gave lots of uh, lead saying that it could be customer supplied encryption key is the one which you should be looking, but nothing is there. You can blame me. I will accept it. But the thing is that that would have hinted you it should be customer supplied encryption key. Basically, that was a hint towards it. That would have helped you in indirectly. Why is that? First, look at this option. Create a dedicated service account and use the encryption at rest to preference at rest to reference your data stored in Google Cloud Storage and Compute Engine as a part of your API. So here, basically, the data is in storage. So no way they are mentioning anything about use the encryption key at rest at your data stored in use encryption at rest to reference your. They have never mentioned how you are going to send the key, generate the key. Option A never even talked about it. Basically, looks like it is mostly towards Google Manage Encryption Key option. Option B and C, I will save time in the exam also, not even reading it. The reason is they directly mention KMS, folks. If key management service is there, what it indicates, the key is going to be stored in Google, which is totally contradicting what it is saying. So B and D, and if you see B is almost 2 sentence or 3 sentence, I can save time, but not even reading it. Okay, so a small trick, if you can make it faster, little faster. So both the options using KMS, so definitely the key is going to be in Google, which will not fulfill the requirement. So I'm only left with D. Let me see whether it is something making any sense. Supply your own encryption key. Good. Use any code, Python code, Java code, anything. Reference it as a part of the API call, meaning you're only using it for reference. You'll never store it. To encrypt your data into Google Cloud Storage and use your Kafka node hosted on this thing. So basically, you reference it whenever you want, but you never store it. This makes more sense. This is one way of finding it out. The other way is A, B, C, D does not even fulfill the requirement. Then you are left with only D. So go with both the options. You should be able to find the answer. You know the answer, mark it and go ahead. You don't know the answer, look for the odd man out. Basically, that's it. So that's the end, folks. That's the end of our storage mod. Now I have 20 minutes. I'm just going to use this to just do a prep for you for tomorrow's class. So let me just close this part. That's our module 4. Tomorrow onwards, we are going to look into the most fascinating part. Control Shift L. What we're going to do now is, yes, this is more like your advanced English. What you learned, that was a good analogy, Vivek. What you learned was English so far. Now we are going to learn advanced English. Where do you recommend to go for more practice on today's? So, okay, Arvind, I'll answer your question towards the end. So I'll answer this. How do you do those parts? So you have some question. I'll answer it towards. So now what we are going to do is networking. This is our module 5. This is the most important thing. As I mentioned on the first day itself, this should be the third module. After introduction to GCP, then IAM, then it should be networking. This is how you see it even in the official materials, all those things. Because without networking, there's no cloud. There's no cloud. But why I push networking towards the 5th module is now you got good hands-on experience with GCP. So on virtual machines, Kubernetes engine, storage, Cloud SQL and all. Now we are in a good position. So now I can slowly pitch in some complex stuffs, which will help you to get the content digested. That was the whole reason. And I did this change based on the various feedbacks which I got from learners like you in the past. So they told it was all good, but it was too much for us to start in the beginning itself. If I had done this on the 5th class or on the 4th class, it would have been an overkill for you people. Now you can digest it. Now you also know the way we take the class doing demos. Now you will be much comfortable there. Some prerequisite, folks. This is the only mantra which we are going to use throughout our networking class. What is this? RFC 1918 standard. You can start counting how many times I'm going to say in networking class. It's going to be close to 50 times this term. What does this stand for? So it's an acronym. It stands for request for comments, basically a specification. What the specification indicates is if you have an IP address and if the IP address falls in this range, then it is going to be marked as a private network. Now, what if it is a private network? So nobody can access it from the outside world. And using this private network, if you try to communicate with the outside world, go to google.com, yahoo.com, the router, the backbone is going to quickly discard to the outside world. So whenever the routers, your ISP provider routers, not the router which you have in your home, the routers which are the backbone of the internet, the moment they see this IP, they will discard it immediately. No private IP address can communicate with the outside world. They will discard it. So this is as per the standards. So you can now, if you ask, can I have something outside of this? You can definitely have it, but it's non-RFC 1918 standard, meaning you can have an IP address which is private, but it is not following this standard, meaning the router will not discard it. You have to do some extra work to block it, communicate with the outside world. But if you have a VM, a Kubernetes cluster with these range, it will never communicate with the outside world, basically. So there are 3 classes which you get, and these are all IPv4 address, 32-bit. So the first class is called as 1 minute, folks. I don't know why it is okay. Let me use my highlighter here. The first one is basically class A. What does this class A means is it starts with 10 dot address space. It always starts with 10 dots address space. It starts with 10.0.0.0, ends with 10.255.255.255. Basically, the 8-bit, the first 8-bit of your CIDR range, classless inter domain routing, that's the acronym for it. So the first 8-bit, which is this 10, is blocked by your network. It's not going to change. It starts with 10, ends with 10, but it's a 32-bit address, right? So 32 minus 8, it's going to be 24 bits are going to be available for you to create virtual machines, meaning 2 power. So if I'm not good at this much complex maths, so I'm just going to do a small math here. So I'm going to use my programmer one. I'll explain you one more time. Scientific. So class A basically means 24 bits are going to be available for you to address to create VMs. The IPs you can use 24 bits. So an IP address is basically 32-bit. It's an IPv4 address. So 32-bit is what available. Now, when it comes to class A, the first 8-bit is reserved by the network. The network will use this. The remaining 32 minus 8, which is 24 bits, are available for you to create VMs. So 2 power 24, if you do 2 power 24, you can address up to 17 or 16 million IP address, 16 plus million IP address. So what it means is, if you have a network which is going to have 10 DOS address space, you can easily address 16 million IPs internally, folks, internally. Now, if you're working in a very large scale MNC kind of a stuff, open up your corporate laptop and just type IP config if it's a Windows machine, or IPA or anything equivalent of that in your MacBook. You will see usually it's going to be 10 dot something. You can verify it for your laptop. So it's going to be always 10 dot. I had worked in a few MNCs like that, like Hewlett Packard Enterprise. Whenever I used to see, it was always 10 dot address space. So the first bit is going to be reserved. The remaining 24 bits are available for you to create VMs. And this is the reason why Google also uses 10 dot address space. They always use 10 dot address space. If you have ever observed, whenever we created a VM, the VM's internal IP was always 10 dot. It was never 127 or 192. It was always 10 dot, because they can address a good amount of IPs. They can use this. And why IPs are important? That is how I can address a virtual machine. That's the logical identification, or the logical address, how I can communicate. So I should have an IP address. Most of you should have seen Rajnikant's movie, right? The Robo. So in the first version of the movie, they would have asked, a police will ask, what's your name? He says, I don't have a name, I have an IP address. So that's how you can address it. So a machine you can address only via an IP address. So basically, you need to have an IP address. And how many IP address I can allocate in my network, that's going to be decided by your range, the IP range which you have it. So hope that makes sense, Kumar. What is /8? Now you know. So /8. Now you have second class of class called as class B, where only 20 bits are available for your IPs, 2 power 24. So if I do that, 2 power 24, close to a million IPs is what you can address. So meaning 32 minus 20, 20. So your network starts with 172.16, ends with 172.31. 31, folks. This is going to be your range. So the first 12 bit is going to be reserved. The remaining 20 bits are available for your VMs. 12 for your network, 20 for your VMs. So a million IP address you can allocate. And this is something very rare to see. You will not see it much in your organization. You will see 10 dot address space. So it's always A is like an upper class, B is like a middle class, C is like the lower class. So either you will see upper class or lower class. Middle class people are always ignored by most of the governments. So C, class C is basically a 16-bit block, meaning the first 16 bit is reserved by the network. The 16 remaining bit is available for your VMs. So 2 power 16, if you do it, 2 power 16, close to 65K IPs is what you can do. Now, if you have a VMware virtual box running in your laptop, most of the time it's going to be 192.168, something like that. You can check it out. So usually if it's a startup, startups will not usually have on-prem these days. But if it's a very small mid-scale organization, they may use 192 address space. Or even in your own personal laptop, if you have some routers or anything configured, or some virtual box configured, it's going to be usually 192.168 address space. So first 16-bit is reserved. The remaining 16-bit is used by your VMs. So the range keeps on going down. Basically, this is the first thing which you should be aware of, and this is very, very important from the exam. They simply ask, the customer wants to have RFC 1918 standard compliant network. How will you do it? So now if you don't know what is RFC 1918 standard, it becomes difficult to answer it in the exam. So this is a very, very important thing from the exam perspective. I'm just going to take a small screenshot and keep it in the cheat sheet. examination cheat sheet, RFC 1918 standard. It means nothing but internal IP, folks, in very, very simple terms, or private IP. If it is so much confusing you, it is nothing but this one. And how do you decide it? It's based on this range. That's it. Based on this range. That's it. Hope this part is clear, folks. Hope this part is clear. Any questions on this? Okay. Now I will just give you a small hint towards the network part. If I just go to the network, create quickly a VM. First of all, let me create a VM with all defaults, not even going to do any change. Just click and create it. Click on create. Just leaving everything default, simply creating a VM. Look at the internal IP address, folks. Forget about the external IP address. After networking class, right, you'll not even think of external IP address. You'll try to avoid it as much as possible. And that's going to be the best practice actually. So let's wait for the VM. You see this? What is this internal IP? It is class A. It is class A. How this is coming basically is, if I go to my network, VPC network, you see this is our network, folks. Only one network is going to be created, and you will see the range for US Central. US Central, you have this. Similarly, if I created in Singapore, right, this is your range. Any VMs which you create in Singapore will always have 10.148.0.0/20. What does /20 mean here, folks? The first 20 bits are reserved. Only 12 bits are available for you to address, meaning 2 power 12. 2 power 12 is what basically should be somewhere 2 power 12. 496 IPs is what you can do. 2 power 12, meaning in a specific region, if you have all the necessary quota with the default VPC, you can go up to 4096 VMs. 4096 VMs. That is what you can do. And Google always uses IPv4 only for their VMs. They don't use IPv6 currently. There is one question. What are the classes on public IPs in? I don't think so. There's any standard for public IPs. Anything outside of this is always public, is my understanding. Internal IP address is very important. Anything outside this is going to be public mostly. And there are a few things called as border gateway protocol, link local IP address. There are some specific series, 169 series and all. There are, but most of them are going to be external. Will there be any increase in the class for IPv6? Basically, at least GCP, right? As of today, they use IPv4 to a great extent. The whole reason is it's all internal. When it comes to internal, right? AWS, if you look into, AWS also uses the same format, folks. RFC 1918 standard only. Only when you have an external presence, you need IPv6, basically. And if you just look into it, most of the organizations are going towards IPv6 because they want to address a huge range. For example, a simple example, right? What is the maximum range you can have? If it's 2 power 32, if everybody uses IPv4, you can have only 4 billion IPs. Now, if you search in internet, look for the entire population of the world, it's going to be 7 or 8 billion, if I'm not wrong. So if you allocate one IP for one individual or so, you are running short of it. That is where people started trying to explore the 128 bit which is your IPv6. So 2 power 128, I would say a very huge number, which can definitely address the entire population, at least for good amount of years to come. So that was the main reason why IPv6 came. But when it comes to GCP, it is going to be still IPv4 only. Okay. Only in one or two places we are going to talk about IPv6. That is when it is external facing, like load balancer, Kumar. Hope that answers your question, Kumar. So it's always going to be, when you use IPv6, it's going to be more, but Google does not support it. The only public cloud provider who emphasizes more on IPv6 is Azure, then is AWS, and Google very less, very less. The main reason could be because the focus is not towards having more of public presence, is my understanding. Wherever it is required, they are using it. But whenever it comes to VMs and all, they don't even provide IPv6. Because the whole intent why Google does that is they have a broad network, one of the largest network of its nature. They can use that private network. Because it's private, they will use only IPv4. They'll use IPv4 basically. So this is something which we are going to use very heavily. And if you wanted to explore more on this IP stuffs, right, there's a very nice website called as Cider XYZ. I would strongly suggest you to play around with it here for at least for 10 minutes or so. You enter the IP, it's going to give you the stuff. Say for example, /28 means what? The first 28 bit is blocked by the network. You see this? This is the first 8 bit, second 8 bit, third 8 bit, and the last 8. First 4 bit is reserved. The 4 bits are not used. No, 28 means 28 bits are reserved by the network. Only 4 bit is available. Only 4 bit is available to everyone, to the network to create VMs, meaning 2 power 16. Sorry, 2 power 4 is 16. Only you can address 2 power 16 VMs. If I make it as 32, only one IP is what you can allocate. This is the IP address. If I make it as 31, 31 bits are reserved, meaning I can create only 2 VMs. I can create only 2 VMs. In GCP, you can go as low as 29, folks. You cannot go 30, 31, 32. You cannot use it. When you create any network, we'll talk why in maybe next Saturday's class. 4 is reserved by Google. 4 is reserved by Google. So if I make it as 30, if you just give it a /30, right? 4 is always going to be internally used by Google. So you will not have any IPs only, IP exhausted. So always have something like 29 is your last subnetwork mask you can use. You can have as low as 8. You cannot go below that. 8 to 29 is what you can have. Okay. So that is something which I wanted to just give as a teaser for tomorrow's class. We'll look into more in tomorrow's class. Let me just stop it now. So where's my slides? So we'll stop it now. So tomorrow there are some more concepts which I need to share with you. OSI model, Google Workspace, all those things. Once I explain those things, then we will jump into our networking concept. And networking is going to become very, I would say, you'll become a fan of networking. At least in GCP, the networking, you'll become a fan. To be very frank, I was having zero knowledge in networking before I started learning GCP. Then the concepts, those things, and I was given an opportunity to try various things, folks. So which made me become a great fan of Google Network at least. So you'll become a great fan is what I would assure you. So we'll stop it now here. If you have a hard stop, you can log off. I'm not going to give any further lectures. I'm going to stop it here. If you have any questions further, I'm happy to answer. So over to you people now. So any questions if you have people on what we did today first? Anything else? I will answer you later. If you have any other questions. Arvind, you had one question. What was that? I told I will answer it after the end. There was something which was there. Was something which
Yeah, so I
is
think two observations. I think, and again, we don't need an answer right now, but I've just quickly checked on Wikipedia. What they're saying is that the Internet Engineering Task Force introduced CIDR to replace the previous classful network addressing architecture. And they say that, whereas classful network designed for IPv4 size the network prefix as one or more 8-bit groups, resulting in blocks of class A, class B, and class C. But under CIDR, the address space is allocated to internet service providers and end users on any address bit boundary. So that's interesting. I mean, and again, even I'm not a networking expert, but it feels like, at least assuming this Wikipedia article is correct, that CIDR has kind of like replaced classful networking.
Okay, classful networking, I would say, usually I would say that internet service provider is the key part, is my understanding here. So whenever it comes to, I'll also explore the classful networking. It's nothing like replacing it, is my understanding.
I mean,
check
they
that.
say replace. I'm just using their word from Wikipedia.
Okay.
And again, I know that Wikipedia is not always correct as well, but it's like a very popular topic.
I also rely on it. So under CIDR range, CIDR address space allocated to. So I'll check it out.
Yeah. And then the only other question I had was on the what was my other question? Yeah, like where do we test ourselves more on today's topics?
So
like what do you
first,
recommend?
so what I would suggest is you have a free tier account activated by any chance? If not, look into the first day recording. Day one.
I actually had it, but it expired, Mahesh. But I think I was watching your video. I was watching your video on YouTube. I think you said that we can just use a different email ID with the same credit card, right?
Yes, it works. I'm using the same credit card for 2 years. It is working. It works. But a new email ID is always important.
Yeah, got it. Yeah.
So use that and create it. That's going to be the way. So what I would suggest is you saw various demos which we did. Now in your free trial account, don't even, and I'll share the recording in next 3 hours or 4 hours. Don't even look into the recordings. Without looking into the recordings, you go play around with the component which we created. See how much you can recollect. That's going to help you to recollect the concept. And for your help, definitely the recording is going to come in next 4 hours or 3 hours. There's a slides. You can look into the slides. You have cheat sheets. You can look into. You have sources, but I don't want you to directly look into it. That is going to give you how much you are able to recollect. In the class, things may look better, but when you start doing it by yourself, that's where you see the challenge. So that way, your recollection capability is going to increase better. That's how I usually recommend.
Clear, yeah.
But your free trial account is the must, is what I would say. Quick labs, you will be restricted by what lab you can do, but here you are not restricted. So you are more like a free bird. You can try everything.
Yeah. I mean, for example, the what you showed, right? You installed some, what was it? Memcache, the Redis CLI, something you installed.
Yeah.
Like it would have never occurred to me that is what I have to install. Like, so that's what I'm trying to say. Yes, definitely we need to explore the services, but how would I know that, I even need to install the CLI?
So thing is that now you install the service, how will you consume it basically? So there should be some kind of a client. So that is what you would have hinted you. So for example, your big table. So for big table, we had CBT inbuilt, so we did not do anything much. For a Cloud SQL instance, you will use a client, MySQL. There are various clients available. Right? So that is the only hint. So when you provision some resource, how do I consume it? Think in that way, you will definitely get an answer. Maybe tomorrow there could be something new coming. How do you consume it? That is the only way. So it is there in the cheat sheet. You can look into it.
Yeah, perfect. Thanks, Mahesh.
Any other questions, folks?
Mahesh, one small question. Can you give me one small example on that vertical scalability? I mean, sorry, horizontal scalability.
Come again, an example on?
Horizontal scalability.
You
Can you
want an
give?
example?
Yeah.
Example of an horizontal scalability is what we did was our managed instance group. Managed instance group.
So it's nothing but it's different regions we do the scalability. That's all right.
No, thing is that horizontal.
Horizontal scaling means you're adding more machine rather than making a machine bigger in the CPU and memory side. Yeah. Suppose you have one application running on one machine and there's a more users. So rather than increasing the size of your machine, what you add more machines, more servers. Or you install the same application in multiple machine and have user come via load balancer, and then users traffic will be sent to each of these machines based on request
Okay,
and
so
traffic.
we'll add more servers, right? More VMs. That's what we are saying, right, Anil?
There's what Anil B was mentioning was absolutely the one. So basically, for example, in on-prem, right, people usually have something like this. You have a user, they hit the load balancer. Something like F5 is a popular load balancer, which is an on-prem. So you have one machine. Now assume your website is running super good first day, because it was less popular. So you had only 4 vCPU and 16 GB of RAM. This can only handle 100, or let's make it little realistic, 10,000 requests per second. First day it was all good. Launch date, not much more coming, so you did it. And later, with word of mouth, all those things, your website is becoming very popular. So every day more than 10,000 requests is coming. Now, if more than 10,000 requests comes, this virtual machine, machine 1 will not be able to handle it. It will have a slowness. So to avoid that, you have two options. One, make the machine more powerful, 8, and make it 32. Then it can handle 20,000 requests. Good. That is one easy way without doing anything much stuff. But how much you can go? So you can keep on going till something like, at least in GCP, you can go up to this much, at least as of today. So you just do the math. It's going to be a good number of resources it can do. But this kind of doing is you are making your the one system more powerful. You are vertically scaling it, meaning you are becoming you are gaining more knowledge. For example, one single person becoming more powerful and powerful, something of that sort. But there's always a technology limit when it comes to vertical scalability, because at that point of time, how many transistors you can have it in your processor, that is going to be controlled. What Intel provides, what AMD provides, that's going to be based on that. You will be limited with it. So this is your vertical scalability. So vertical scalability will always have basically a technology limit. Vertical scaling technology limit is going to be there, whatever it is. Now technology limit is there. So instead of doing this, what you do is you don't make it like this. You keep it back to 4 only, 16 only. Instead of that, you add a new machine, an identical copy or a carbon copy. Now maybe in the beginning you may not even need a load balancer. Later, when you add a VM, 2 VMs, then you add a load balancer to balance the load between 2 VMs. Now you have not even done any changes. You have added a copy, identical copy. How do you create an identical copy in GCP? With the help of your templates, custom images. So now it can handle 20,000 requests. Tomorrow, if more requests comes, you need to add more VMs. You keep on adding VMs. Now, there's no technology limit. No technology limit here. The reason is I can add n number of servers as I want. What is the only limit? Your budget. How much your credit card can bear as the upper limit. Your budget is the limit, is the only limit in horizontal scalability. So, and this is the reason why products like Hadoop shined very well. Because if you see Oracle and all, they work on only one server. Most of the databases, monolithic applications, they work on a very powerful server. To purchase that very powerful server, most of my budget is going to go off. But instead of me spending on a heavy uh, or a very high configuration server, use very low scale machines, join them together. This is, I would say, like in very, very simple terms, horizontal scaling is like a group effort or a group job. What is that called?
Teamwork. Teamwork. Yeah.
Teamwork. Vertical scaling is like a one-man army doing it. So that one-man army can fail anytime. So that's what I would say in a very simple terms.
Yeah, I got it. Actually, I mean, I remember when you explained on the MDG, you explained very well, but I forgot actually. It's more,
No
more
problem.
yeah, thank you very much, Mahesh. Thank you, Anil. Actually.
Yeah.
Yeah, bye
Any
guys.
other questions, folks?
Mahesh, I've just
Yeah.
forgot one thing.
Hmm. Yeah,
Actually, I forgot the use case of unmanaged instance group. Which kind of application we can provision for unmanaged? It is of very old topic, so that's why I was waiting for my turn. So the use case of unmanaged instance group, where we have to use it. I mean, I know some
So
legacy systems. Yeah.
yeah. So I guess I had mentioned this. So I guess I remembered I was saying it. So whenever it is an on-prem to GCP migration, you have unidentical systems. Say for example, this entire setup, right? Assume this is in on-prem only. So you started with this. Uh, or let's make it a little more powerful. Uh, This is what you had. Now it is serving this much. Now request. Now later more request is going to come. Then you ask for more CPUs from your on-prem infra people. Then they can say they cannot provide you exactly 16 vCPU. We can provide you half is what they will say. So then you have something like this, which can serve this much of request. Now website continues working, but now still more request comes. Now again, if you reach out to your infra people, they will say no, we cannot provide more. We can provide you still what we can provide. This is what we can afford. So they provide you half, still half of it. Now basically what is happening now, you can serve around 17,000 requests per second, but everything is done via a unidentical VMs. Now, if you basically want to do this lift and shift, if you want to move this to cloud, what you do is you create a unmanaged instance group. Unmanaged instance group is going to be a good fit here because you don't do any change. Get the same thing. M1 is going to be 16 vCPU. M2 is going to be 8 vCPU. M3 is going to be 4 vCPU. As is, make it and make it work. Simple. Lift and shift. Once the customer sees, okay, there's a value in cloud, slowly then ask them to suggest, why don't we look into something like MIG? Why? Because unmanaged instance group only supports load balancing. When you come to MIG, you get auto scaling, auto healing, auto upgrade, all those things. So this is where I usually see unmanaged instance group helpful. And quickly to do some demos to a VM. This is real use case. As a cloud architect, if you were to do some quick demo where you have a you need a load balancer, L7 load balancer, and you want to show it, I usually create this unmanaged instance group, attach it to a load balancer and show it. We will do one more. We will do a demo on unmanaged instance group maybe next Sunday, if I'm not wrong, where we talk about load balancer. At that time, I'll show you this part where we do, because we have already done a managed instance group demo. Unmanaged instance group demo, we'll show you that. But one use case is lift and shift, Vivek.
Thank
Usually
you.
for lift and shift.
Yeah, I just it was like I forgot that what was the use case actually.
Yeah.
Right. And one more thing, like I was saying, the network connectivity center.
I'll say, what is that called? Network? I'll just check it. Never heard. I did not even see. Maybe I did not see that article. Network Connectivity Center. Huh?
Have you heard about Aviatrix?
Sorry?
Have you heard about Aviatrix? Aviatrix multi-cloud networking?
No. If you can put
Actually,
the text there, if you can put the text.
Give me a minute.
Not looked into it, so connectivity.
It's Aviatrix. Actually, thing is that I just read something like network connectivity is like until now Google doesn't support third-party router or SD-WAN. Okay, now they have provided a hub and spoke kind of some functionality in which you can monitor your network and can provision SD-WAN and some third-party router to connect your branch office, which you cannot connect via VPN or something. Until now, I can see only dedicated router VPN support is
The one
there.
which you're saying, network connectivity overview. Is this what you're saying? It's in preview. Okay, it's in preview.
Azure and AWS is having that. They can connect via SD-WAN, third-party router. Until now, Google don't have anything till 24th of March. So now they are also offering a solution to connect SD-WAN and some third-party router to connect your remote offices which cannot be connected like via VPN and all. I think is this the some kind of funda means until now it was like Google Cloud to data center. Now Google Cloud to branch site also.
Got it.
So I need to read it thoroughly, but I know this functionality was not available, and due to that, there was some restriction at network level. Also means you cannot connect your partner site. Your partner want to connect your GCP, but there was no way to connect. Partner cannot directly connect to you. Aviatrix is a monitoring like system which provides a hub and a spoke for multi-cloud networking. It's very hot nowadays. Yeah, it's quite hot, and they are giving free certification until April.
Okay, I saw something like this in some. I saw this in someone post there. Yeah, but I didn't recollect the name.
Deploy from Google Market this Aviatrix system.
Marketplace.
And a spoke functionality in which you connect your VPCs to Aviatrix and monitor your complete network from single pane. Means only one window. Not to go. There is no need to go to GCP to monitor where the packets are moving, who's trying to connect me, whom I want to connect. Subnet type mask means subnet wise, FQDN wise, you can whitelist, blacklist in Aviatrix. So some kind of functionality Google trying to bring in, like I think so in Google Network Connectivity Center, like single pane of glass, what it says, you monitor your complete network. You have a 200 VPC, let's say I'm saying it's very difficult for you to monitor those 200 VPCs. So as of now, Aviatrix is the system which provides a pane that you can connect 200 VPC to my Aviatrix system and monitor your each and every system and provide control also. Means you not to create a explicit firewall. You just create a firewall at Aviatrix. If that passes through, then it will go to cloud. Otherwise, it block your request at the Aviatrix level itself.
Got it.
If their VPN provide up to the speed the service provider provides, like I know that GCP doesn't provide, or some AWS and all. 3 Gbps I think is the limitation of VPN. They say if you support 80 Gbps, my VPN support 80 Gbps also. So, yeah, that's why I'm talking. It means connectivity center is such.
Okay, let me see that. But what is provided by the service provider is what they provide, is what you're saying, right?
Whatever means I tell you, if you are interconnect, if you are having an interconnect,
200 Gbps, you will have 200 Gbps.
So via using their VPN, you can get a speed of 80 Gbps. That is the limitation of their VPN also. They have a up to 80 Gbps. Their VPN limitation is 80 Gbps. Whatever is your service provider or network provider can provide, I mean, Google Cloud provider, they can support maximum up to 80 Gbps. I'm not briefing Aviatrix. Actually, I was briefing Google Network Center, I think Connectivity Center, which I saw similar to this actually. Aviatrix is quite vast. Network Connectivity Center is just, I think it's in beta and something. Until now, you cannot connect the, I told you, like partner site. I think they are trying to connect partner site also by this functionality and to monitor your network also, which I think this is the thing which they are going to provide.
Got it. Something new. I did not even explore this. Yeah. On-prem to GCP is where the requirement comes. Yeah. Good.
To start network, or that's I read this news. I thought I should tell to everyone
Thank you.
to read this thing, because this is the thing where we I mean GCP lacks, means they cannot provide partner connectivity, means GCP to partner. So I know Azure and AWS do provide by using SD-WAN and other router functionality, where they are trying to fill the gap by using this service.
Got it. Good. Good to know
Thank
that. Thanks, Vivek, for sharing this.
Vivek, when you are going to give us party, you got two interview cracked, right? So when is the party?
It should be a e-party, or maybe you have to make sure you send pizzas or something, order it.
We cracked two interviews successfully, right? After your training.
BOYL, Mahesh, it is BOYL. Bring your own license.
Okay, bring your own license.
Means I cannot. I don't know. Now someone is in US, someone is in Singapore, someone is in Europe. So bring your own pizza and send me the bill.
Bring your own lunch.
No, in terms of marketplace, I have given the answer.
Correct. Good.
So maybe by the Monday or Tuesday, Wednesday, I'll be getting an offer later. So yeah, thank you, Mahesh. Also, or your teaching also helped me a lot.
Good. All right,
when
folks.
when I was reading alone,
Yeah, good.
it was very narrow. You have given a wide scope to learn the thing. Thank you very much.
Okay. Yeah.
Bye.
My pleasure, Vivek. So, all right, folks. Is there any last questions which you have?
It's fine, sir. Okay.
Good. All right, folks. If there's no more questions, I'll send you the recording soon as it gets processed. I'll send you out, and you should be able to see it. So tomorrow is going to be more interesting. Networking. Lots of very basic stuffs also we'll explore. Very high funda concepts like VPN also we'll explore. Okay. See you tomorrow, folks. Thank you.
Thank you, sir.
Thank you. Bye.